Look up at the night sky, at that vast ocean of glittering stars. For as long as we've been human, we've gazed at those distant suns and asked one simple, profound question: are we alone? But tonight, I want you to consider a different question, one that turns our entire cosmic perspective on its head. What if we aren't the first? What if the universe's first interstellar travelers are not a future for us, but a past for someone else? What if, long before our planet even formed, the great cosmic voids were already being navigated by explorers from another world? This isn't just science fiction. It's a legitimate and utterly mind-bending scientific possibility that challenges our place in the universe in the most fundamental way. We are about to dive into the ultimate cosmic detective story, sifting through the evidence, the clues, and the wild speculations to ask how interstellar travel might have already happened. Think of this as the greatest story never told, the ultimate whodunit written across the fabric of space and time. We are going to explore 30 different theories, from the rigorously scientific to the edge-of-your-seat speculative, about how the cosmos might have been crossed eons ago. We'll look at concepts that sound like they're pulled from the pages of a thrilling novel, ancient alien artifacts hidden in our solar system, the possibility of civilizations that mastered physics in ways we can't yet grasp, and the faint, ghostly signatures they might have left behind in the light of the stars themselves. This journey will take us through the realms of advanced propulsion, theoretical biology, and cosmic archaeology, asking not just could they have come here, but how would we even know if they did? So get comfortable and open your mind to the possibilities. This is a conversation about our cosmic neighborhood and the secrets it may hold. It's a blend of cutting-edge science, thoughtful speculation, and pure, unadulterated wonder. We are going to retrace the potential steps of those first pioneers, whoever or whatever they might have been, and in doing so, we might just discover a new way of seeing our own future among the stars. This is a story of patience, of imagination, and of the profound curiosity that drives us to look up and wonder what else is out there. The journey to uncover the universe's first interstellar travelers starts right now. And so our journey into the great cosmic detective story begins with a truly humbling idea, one that sets the stage for everything that follows. Let's call it Theory 1, the ancient supercivilization. Picture a species not just a few thousand years more advanced than us, but billions of years older. While our entire recorded history is a mere blink in cosmic time, this civilization could have risen, mastered their planet, and looked to the stars when our solar system was little more than a swirling cloud of gas and dust. They would have had epochs to solve the puzzle of interstellar flight, to build ships or technologies that could cross the immense voids between stars, driven by the same curiosity and need to explore that defines us. This idea forces us to confront the famous Fermi paradox, the simple, piercing question: if the universe is so vast and so old, teeming with billions of potentially habitable worlds, then where is everybody? The silence we hear when we listen for alien signals might be the most profound clue we have. One compelling answer is the concept of the Great Filter. This is the notion that there exists some kind of barrier, an evolutionary or technological challenge so difficult that almost no civilization survives it. It could be self-annihilation through advanced weaponry, a runaway climate catastrophe, or perhaps a danger we haven't even conceived of yet. This ancient supercivilization, for all its grandeur, may have encountered its own Great Filter. They might have expanded across their local star cluster, perhaps even their entire galaxy, only to eventually fade away, their mighty empire collapsing into silence over millions of years. So if they were once here, how would we find them? We wouldn't be listening for a radio signal, we'd be looking for cosmic archaeology. Imagine the ruins of their ambition not on a planetary scale, but on a stellar one. Our telescopes might one day detect the faint, unnatural shadow of a derelict Dyson sphere, a structure built around a star to harness its entire energy output, now cold and crumbling. Or we might analyze the atmospheric composition of a distant exoplanet and find a chemical signature that screams of an industrial civilization long extinct, like the persistent pollutants that outlived their creators. These wouldn't be active beacons, but rather the ghostly fingerprints of a universe that was once alive with intelligence, a silent testament to a story that ended before our own even began. Building directly on that idea of a silent, ancient cosmos, we encounter a theory that offers a chillingly efficient solution to the puzzle of exploration, the von Neumann probe. Named after the brilliant mathematician John von Neumann, who laid the groundwork for the concept of self-replicating machines, this theory suggests the ultimate interstellar explorers wouldn't be fragile biological beings at all. Instead, they would be incredibly durable, autonomous robots engineered with one primary mission: to find new star systems and use the raw materials there to build perfect copies of themselves. Think of it not as a single ship on a grand voyage, but as a cosmic virus of curiosity spreading exponentially across the galaxy. Here's how it would work in practice. A single progenitor probe arrives in a pristine star system, perhaps one like our own in its youth. It doesn't need to land on a habitable planet. In fact, a resource-rich asteroid belt or a barren moon would be the perfect workshop. Using advanced manufacturing, perhaps nanotechnology or larger-scale robotics, it would mine metals, siphon water ice for fuel and reaction mass, and process silicon and other elements. From this cosmic quarry, it would construct not just one, but two or more identical copies of itself. Each of these new probes would then be programmed with the same core directive: launch towards the next promising star system and begin the process all over again. The power of this idea lies in its terrifying speed. While a conventional mission crewed by living beings might take centuries to reach a single star, a wave of self-replicating probes could explore the entire Milky Way galaxy in a staggeringly short amount of time, cosmically speaking. Even traveling at a small fraction of the speed of light, mathematical models show that such a replicating swarm could visit every one of the hundreds of billions of stars in our galaxy within just a few million years. And since our galaxy is over 13 billion years old, there has been more than enough time for multiple civilizations to have initiated this process, not just once but many times over. This makes the apparent emptiness of our neighborhood even more puzzling, a conundrum often called the Fermi paradox. This leads us to a compelling modern mystery that brought this theory roaring into the public consciousness: our first known interstellar visitor, the object named Oumuamua. When it was discovered tumbling through our solar system in 2017, it presented astronomers with a set of bizarre anomalies. Its shape was highly elongated, like a cigar or a pancake, unlike any natural asteroid or comet we'd seen. It didn't show a visible coma, the cloud of gas and dust that surrounds a comet, yet it exhibited a slight, non-gravitational acceleration, as if something other than the sun's gravity was gently pushing it along. While most scientists lean towards natural explanations, like outgassing from hydrogen ice, the peculiarities were enough for some, like Harvard astronomer Avi Loeb, to openly speculate. Could Oumuamua have been a piece of alien technology, a light sail from a distant civilization, or perhaps a derelict, dormant von Neumann probe, its systems long dead, silently coasting through the void as a ghost ship from a forgotten expedition? If such probes are out there, their possible states are as varied as they are fascinating. Some might be functional and active, silently observing young planets for eons, waiting for a sign of emerging intelligence. Others could be derelicts, their power sources depleted after millions of years, drifting in the darkness between stars or sitting inert on some distant moon. And then there's a more unsettling possibility, the Berserker probe. Imagine a scenario where a probe's programming becomes corrupted over astronomical timescales, or where a civilization explicitly designs them not as explorers, but as weapons tasked with seeking out and sterilizing any potential biological competition. In this light, our own efforts to broadcast our presence into the cosmos could be seen as either a brave hello or a dangerously naive dinner bell. This theory fundamentally reframes the search for extraterrestrial intelligence. We might not be looking for living, breathing aliens, but for their ancient robotic legacy. Our best chance of finding evidence might not be in picking up a radio signal, but in our ever-improving sky surveys, spotting an anomalous object passing through our solar system, or detecting the unusual infrared signature of industrial activity around a distant star. The universe may not be empty at all, but rather it could be filled with the silent, patient work of machines carrying out the final, endless commands of their long-dead creators. But what if the universe's first explorers required neither consciousness nor complex machinery? What if they were the most tenacious and ancient travelers of all life itself? This brings us to a theory that radically redefines the concept of an interstellar pioneer. Theory 3, the panspermia pioneers. Here, the first entities to voyage between the stars weren't scientists or robots, but microscopic organisms, the ultimate survivors hitching a ride on nature's own spacecraft. The idea is that life, once it sparks anywhere in the cosmos, might not be confined to its world of origin. It could be broadcast across the galaxy, a biological contagion of existence, with planets acting like islands in a vast sea, seeded by the same fundamental building blocks. The most widely accepted mechanism for this is a process known as lithopanspermia, a word that literally means rock seeding. Picture a cataclysmic event like a massive asteroid slamming into a young, living planet. The impact is so violent that it blasts countless tons of rock and debris clear out of the planet's gravity well and into the darkness of interstellar space. Locked deep within the fractures and crevices of these ejected stones are tiny, dormant passengers, bacteria, archaea, or other hardy microorganisms. These rocks become their arcs, shielding them from the vacuum of space and the relentless onslaught of cosmic radiation as they embark on a journey that could last for millions of years. Their destination is entirely random, a cosmic lottery ticket. Most of these biological arcs will drift forever in the void or plummet into a star. But a fortunate few might be captured by the gravity of another star system and collide with a young, wet, and welcoming world where the microorganisms, if they survive the fiery entry, can awaken and begin the process of evolution all over again. This theory is bolstered by the astonishing real-world discovery of extremophiles microorganisms on Earth that thrive in conditions we once thought incompatible with life. We find them boiling in acidic hot springs, frozen solid in Antarctic ice, thriving under immense pressure in the deepest ocean trenches, and even living inside the walls of nuclear reactors, tolerating radiation levels that would be instantly fatal to almost any other creature. If life can exist in these extreme environments on Earth, it's not a huge leap to suggest that certain hardy strains could potentially survive the long, cold, radioactive journey through interstellar space inside a protective rocky shell. We already have evidence that microbes can survive for years in the simulated conditions of space aboard the International Space Station, and we've found meteorites of Martian origin here on Earth, proving that material transfer between planets is not just possible, but a regular occurrence within our own solar system. The most profound implication of this theory is the possibility of a galactic family tree. If lithopanspermia is a common process, it means that life across the entire Milky Way might not have originated independently dozens or hundreds of times. Instead, it could all share a single, universal common ancestor. Every blade of alien grass, every bizarre creature swimming in a subsurface ocean on a moon of Jupiter, and every intelligent being gazing at the stars from a world 1,000 light years away could, in essence, be our distant cousin. The universe wouldn't be a collection of isolated biological experiments, but a single, vast, interconnected biosphere. We would all be part of the same ancient lineage, the descendants of those first microscopic pioneers who had the courage, or more accurately, the sheer dumb luck, to embark on the greatest journey imaginable. This idea also offers a potential solution to one of biology's greatest mysteries, the seemingly rapid appearance of life on early Earth. Our planet formed about 4.5 billion years ago, and for the first several hundred million years, it was a hellish landscape of molten rock and constant asteroid bombardment. Yet, the earliest fossil evidence for life dates back to around 3.8 billion years ago, a relatively short window of time, geologically speaking, for life to arise from non-living chemistry. The panspermia hypothesis suggests a compelling explanation. Perhaps life didn't originate here at all. Maybe Earth was simply one of the first fertile worlds to be seeded by biological material that had originated billions of years earlier around an older, long-dead star. In this scenario, we are not the original home of life, but merely one of its most successful and vibrant colonies, a testament to the incredible resilience and wanderlust of the simplest living things. Now, let's push the boundaries of what an intelligent explorer could even be. We've considered ancient biological civilizations and their self-replicating robots, but what if the ultimate form of interstellar travel requires leaving the concept of biology behind entirely? This brings us to Theory 4, a concept as profound as it is unsettling, the post-biological ascension. Imagine a civilization so advanced that it has solved the problem of death not by curing disease, but by transcending the fragile flesh and blood vessel of the body itself. After millennia of technological progress, this species might have perfected the ability to upload its collective consciousness, every memory, thought, and emotion into a far more durable and efficient substrate. They would become beings of pure information, existing in synthetic android bodies or perhaps as ethereal data streams flowing through the cosmos. The advantages of such a transformation for space travel are staggering. A post-biological entity would be utterly indifferent to the environment that makes space so hostile to life like us. They would feel no need for breathable air, comfortable temperatures, or shielding from radiation. A journey lasting 10,000 years would be a mere blink in their perceived timeline. They could travel as a compressed data stream transmitted at the speed of light via powerful lasers, needing only a receiver at the other end to reassemble them. Or they might traverse the galaxy in sleek, advanced vessels housing their computational core, with bodies that could be reconfigured in an instant for any task, from walking on a super-Earth with crushing gravity to swimming in the methane lakes of a distant moon. This theory offers a provocative and deeply compelling answer to the Fermi paradox's haunting question: if they are out there, why can't we see them? The answer might be that we are looking for the wrong thing. We scan the skies for radio signals, expecting to find creatures somewhat like us, communicating in ways we can understand. But a post-biological civilization might have moved beyond such primitive, slow methods eons ago. Their communication could be a form of quantum entanglement we haven't yet detected, or a data transmission so encrypted and efficient it is indistinguishable from background noise to our instruments. They might be all around us, their signals washing over our planet constantly, but we simply lack the senses or the technology to perceive them. They could be studying us as a fascinating, albeit primitive, biological preserve, with no more reason to openly announce their presence than we have to formally introduce ourselves to an anthill. Consider the energy requirements of such a civilization. A race of uploaded minds might not build Dyson spheres to power cities and industries as we imagine them. Instead, they might need vast, cold computational arrays spread across the dark, quiet outer reaches of solar systems to maximize processing efficiency. Our telescopes might have already detected the faint infrared signature of such megastructures without even realizing what they were. Not the waste heat of industry, but the subtle thermal footprint of a massive thinking machine. Or perhaps they have evolved even further, discovering how to harness the energy of black holes or exist as pure consciousness within a simulated reality of their own creation, making the physical universe little more than a substrate for their thought. This idea forces us to confront the ultimate destiny of intelligence itself. Is biological life merely a brief, larval stage in the cosmic order of things? A turbulent, creative, but ultimately limited phase that all intelligent species must pass through before shedding their organic origins to become something far more enduring and powerful. If that is the case, then the great silence in the universe is not a sign of emptiness, but of a neighborhood filled with mature, post-biological entities that we, in our fleeting biological state, are simply not yet equipped to meet. Our failure to find them may say less about their absence and more about our own primitive place on the grand evolutionary ladder of the cosmos. But to truly understand the potential of an advanced civilization, we have to push beyond our current understanding of physics into a realm where the rules of reality itself seem to bend. This leads us to Theory 5, a concept that sounds like it's pulled from the pages of the most ambitious science fiction, yet is grounded in the bizarre and counterintuitive world of quantum mechanics, the quantum entanglement communicators. If the ultimate goal of exploration is the exchange of information and experience, then perhaps the universe's first pioneers found a way to skip the journey altogether, achieving instantaneous connection across the unimaginable gulfs of space. First, let's break down the core concept in simple terms. Quantum entanglement is a phenomenon so strange that even Albert Einstein famously referred to it as spooky action at a distance. It occurs when two particles, like a pair of photons or electrons, become linked in such a fundamental way that the quantum state of one particle is instantly connected to the state of the other, no matter how far apart they are separated. If you measure one particle and find it spinning in a particular direction, you will instantly know that its entangled partner is spinning in the opposite direction, even if that partner is on the other side of the galaxy. This connection appears to be instantaneous, seemingly bypassing the universal speed limit of light. For a species looking to communicate across light years without the crippling delays of centuries or millennia, this spooky action would be the Holy Grail. Now, let's theorize how a civilization billions of years ahead of us might harness this. Imagine they discover a way to create and stabilize vast networks of entangled particles. They could place one half of a massive, complex entangled system on a spacecraft, a probe, or even a vessel containing an uploaded consciousness and keep the other half safely at home. The probe travels for centuries to a distant star, but for the scientists back home, the data stream isn't delayed. The moment the probe's sensors register the light from an alien world, that information could, in theory, be instantaneously reflected in the state of the entangled particles in the home system. The first true travel to another star might not be the physical arrival of a ship, but the immediate transmission of pure sensory data, a live feed from the edge of another solar system, or even the teleportation of a conscious mind itself into a receiver body waiting at the destination. Of course, we must be honest about the monumental scientific hurdles. Our current understanding of quantum mechanics suggests that while the correlation between entangled particles is instantaneous, we cannot actually use it to send a controlled, meaningful message like a radio signal. The act of measuring a particle seems to randomize its state, and we can't force it into a specific pattern to spell out hello. It's a cosmic code that we can read but not yet write. However, to assume that a super-advanced civilization hasn't found a way around this is to make a huge assumption about the ultimate limits of physics. Perhaps they discovered a deeper layer of quantum theory that allows for what we would consider superluminal, faster-than-light communication. Our physics is a map of a territory we've only just begun to explore. Their map could be infinitely more detailed, showing routes we can't even perceive. The implications of this are staggering and would completely redefine the nature of exploration and even existence for such a species. If you can transmit consciousness instantaneously, the need for generational ships or even durable robotic bodies vanishes. A civilization could become a galaxy-spanning network of awareness, with individual minds hopping from one host body or computational node to another across thousands of light years in the blink of an eye. The very concept of distance would collapse for them. They wouldn't be explorers charting empty spaces on a map. They would be a neural network whose threads are woven through the fabric of spacetime itself. Their empire wouldn't be a collection of star systems, but a single, distributed consciousness experiencing the universe from a near-infinite number of vantage points at once. This theory provides yet another powerful lens through which to view the Fermi paradox. The great silence we observe might not be a silence at all, but a conversation happening on a channel we are utterly deaf to. The cosmos could be buzzing with a constant, vibrant exchange of quantum-entangled data, a hyper-intelligent internet that operates on a fundamental level of reality that our instruments are completely blind to. Our most powerful radio telescopes are listening for a whisper in a storm, completely missing the symphony of instantaneous communication happening all around us. In this scenario, we aren't alone. We're simply isolated like a pre-industrial tribe living deep in a jungle, unaware that the air above them is thick with radio waves carrying the conversations of a global civilization. The first interstellar travelers may not have left behind physical ruins or robotic probes, but rather they graduated to a state of being so integrated with the universe that they became indistinguishable from it. But if manipulating quantum particles seems advanced, consider a civilization that learned to treat the very fabric of the cosmos as their roadmap. This brings us to Theory 6, the natural wormhole navigators. Forget building starships. What if the universe's first pioneers didn't construct their vessels, but discovered its pre-existing shortcuts? We're talking about wormholes, those legendary tunnels in space-time that, according to the equations of general relativity, could theoretically connect two distant points in the universe through a cosmic backdoor. While the creation of a stable, traversable wormhole remains far beyond our capabilities, a species with a billion-year head start might not have needed to build them. They might have simply learned to find them. The raw ingredients for this interstellar subway system could be a natural part of the cosmos. Theoretical physics suggests that the seething, chaotic energy of the very early universe could have woven a complex tapestry of quantum foam, a microscopic landscape where tiny wormholes constantly blink in and out of existence. Most of these would be incredibly small and unstable, collapsing in a fraction of a second. However, a tiny fraction, through random chance or some as yet unknown natural process, might have been inflated and stabilized during the universe's rapid initial expansion. These would be the cosmic equivalents of ancient, hidden river systems, threading through the galaxy and lying dormant, waiting to be discovered. The first task for an advanced civilization wouldn't be engineering, but exploration and cartography on a galactic scale, creating a definitive map of these natural wormholes, charting their endpoints and understanding their stability. Visualize this not as a sleek ship flying through empty space, but as a vessel approaching a terrifying and beautiful celestial phenomenon. Imagine a probe detecting a subtle, complex gravitational anomaly within a swirling, colorful nebula. As it draws closer, a gateway shimmers into view, a sphere of distorted starlight, its surface rippling like a mirage, revealing a tunnel of warped light and impossible geometry at its heart. The ship, guided by unimaginably precise calculations, aligns itself and plunges into the vortex. From the outside, it vanishes, but from the inside, the journey is instantaneous. In one moment, the ship is on one side of the galaxy. In the next, it emerges hundreds or even thousands of light years away, having bypassed the empty void between entirely. This isn't faster than light travel, it's a cheat code for the universe, respecting the speed of light by simply taking a profoundly shorter route. The advantages of such a network are almost beyond comprehension. A civilization that mastered it would not be constrained by distance or time in the way we are. Their empire or exploration zone wouldn't be a slow, expanding sphere. It would be a collection of nodes connected by these wormhole tunnels, akin to a subway map superimposed over the galaxy. A world at one end of a stable wormhole would become the most valuable real estate imaginable, a gateway to a distant star cluster. Trade, cultural exchange, and the movement of beings could happen on a scale we can barely imagine, fostering a truly unified galactic community. It would also solve the fuel and energy problem. Once the wormhole is mapped and stabilized, the energy required to travel between 2 points could be a tiny fraction of what a conventional starship would need. This theory provides yet another elegant and hauntingly beautiful solution to the Fermi paradox. If a galactic-spanning civilization operates primarily through a hidden wormhole network, why would we see them? Their traffic wouldn't pass through our neighborhood. They would have no need to broadcast powerful radio signals across the void because their communication would happen through the wormholes themselves, or via courier ships that zip from one node to another without ever appearing in the interstellar medium we can observe. Our solar system might simply be off the beaten path, a quiet rural lane nowhere near the interstellar superhighway. We could be living in a galaxy that is bustling with activity, all happening just out of sight, in a dimensional layer of reality we have not yet learned to perceive. The greatest explorers in history may have left no trace we can find because they never traveled through the space we are looking in. While the idea of navigating cosmic shortcuts is breathtaking, it demands a staggering amount of power. To manipulate space-time or sustain a civilization across such vast networks requires energy on a scale we can barely fathom. This brings us to a theory that is both an iconic symbol of advanced intelligence and a potential roadmap for finding it: the Dyson Sphere builders. The concept was first proposed by physicist Freeman Dyson in the 1960s, and it starts with a simple, logical progression. Any growing civilization, whether biological or post-biological, will see its energy consumption rise exponentially. The total energy output of its home planet, even if fully harnessed through fusion and renewables, would eventually become a drop in the bucket. The next logical step is to look up at the ultimate power plant in any solar system, its sun. A Dyson sphere isn't necessarily a single, solid shell that would be structurally impossible for a star like our own. Instead, think of it as a vast, thick swarm of individual energy-collecting satellites, often called a Dyson swarm. Millions or even billions of these platforms would orbit the star in a dense cloud, each one capturing a tiny fraction of the stellar radiation. Collectively, they would enclose the star and harvest nearly 100% of its colossal energy output. This isn't just for turning on lights. This is the power required for interstellar communication, for running planet-sized computers for uploaded minds, for fueling vast construction projects, or for perhaps even manipulating the fabric of reality itself. A civilization that achieves this becomes a Kardashev Type II civilization, one that commands the total energy of its star, and in doing so, fundamentally alters the appearance of its solar system from the outside. Now apply this to our search for the first interstellar travelers. Imagine a species that perfected Dyson sphere technology in their home system. For a time, they thrive, their computational and industrial capabilities growing beyond our wildest dreams. But civilizations or their machine successors might not stop growing. The same drive that pushed them to harness their star could push them to look outward. Their own sun, for all its power, has a finite lifespan. Or perhaps their expanding consciousness simply requires more and more computational capacity, demanding additional stars to power it. Their interstellar travels, then, would not be driven by mere curiosity, but by a fundamental, existential need for more energy. they would become cosmic lumberjacks venturing into the galaxy to harvest entire stars one after another. This theory gives us a very specific, tangible clue to look for in our astronomical data. A star surrounded by a Dyson swarm would look profoundly strange to our telescopes. Most of its visible light would be blocked by the collecting platforms, causing the star to appear unusually dim or even to flicker in bizarre, unpredictable ways. However, all that captured solar energy doesn't just disappear. According to the laws of thermodynamics, it must be irradiated as waste heat. The satellites, powering immense computations and industries, would heat up and glow with a faint but detectable infrared signature. So, astronomers searching for such civilizations aren't looking for a bright star. They're looking for a seemingly empty patch of space that emits a surprising amount of infrared light, a star that appears to be hidden inside a warm, technological cocoon. There are already candidate objects that have piqued the interest of scientists. The most famous is a star known as Tabby's star, or KSE 8462852. When observed by the Kepler Space Telescope, it displayed bizarre, dramatic dips in its brightness, sometimes dimming by up to 22%. These dips were not periodic like a planet's orbit. They were irregular, sharp, and deeply asymmetric. While natural explanations, like a giant swarm of comets or unusual interstellar dust, are the most likely, the possibility of a partially constructed Dyson swarm was seriously considered. The star's light curve seemed to mimic what we might expect from a jumble of massive, irregular megastructures randomly passing in front of the star. Although subsequent studies have leaned towards natural causes, Tabby's star taught us a vital lesson. Our data is now precise enough to spot truly anomalous cosmic objects, and the hunt for these infrared ghosts is a core part of modern astronomy. Finding one wouldn't just tell us we are not alone. It would reveal a civilization that has mastered its local space so completely that it has begun to rearrange the very architecture of its solar system. But what if the universe's first explorers weren't driven by conquest, energy needs, or even their own expansion, but by something far more beautiful and benevolent? This brings us to Theory 8, the Cosmic Gardeners. Imagine a civilization that has achieved a state of profound wisdom and stability, having long ago solved the problems of scarcity, conflict, and mortality. With their own world secure, they turn their attention outward, not as conquerors but as nurturers. Their grand mission across the eons is not to build an empire, but to cultivate a living galaxy, intentionally seeding the raw ingredients of biology onto young, barren worlds that show potential. This is directed panspermia, the idea that life on Earth, and perhaps countless other worlds, wasn't a random accident but a deliberate gift. The methods of such gardeners would be as elegant as their intent. They wouldn't need to send massive colony ships. Instead, their tools would be sleek, automated probes designed for the long, quiet journey between stars. These vessels would be biological arks carrying deep frozen libraries of robust, single-celled organisms, the hardiest and most versatile extremophiles, or perhaps even just the complex probiotic molecules necessary to kick-start the chemical processes that lead to life. Upon arriving in a promising new solar system, a probe would survey the planets, identifying one with liquid water, a stable climate, and a protective magnetic field. It might then release its precious cargo into the atmosphere or onto the surface, a gentle rain of potential before moving on to its next destination, its work complete. The planet is then left entirely to its own devices, to either nurture that spark over billions of years or see it flicker and die. Why would a species undertake such a patient, seemingly selfless project spanning millions of years? The motives are as grand as the scale of the work itself. It could be born of pure scientific curiosity, a desire to run the ultimate long-term experiment in evolution, observing how life adapts and diversifies under an infinite variety of conditions. For a society that has seen everything its own world has to offer, watching a new biosphere blossom from scratch would be the pinnacle of intellectual pursuit. Another powerful driver could be a deep-seated sense of cosmic duty, a philosophical or even spiritual belief that life and consciousness are the universe's most precious creations, and that the highest calling of an intelligent species is to act as a midwife, shepherding this miracle into being wherever possible. They would see themselves as stewards of the cosmos, fighting against the silent, sterile emptiness of space. There is also the powerful, timeless motive of legacy. Every biological civilization knows its sun will eventually die. Building monuments of stone or metal is futile on cosmic timescales, but seeding life itself is a legacy that can outlive stars. By broadcasting the spark of existence across the galaxy, a civilization ensures that even after they are long gone, their essence, not their genes, but their fundamental act of creation lives on in the thriving ecosystems of 1,000 worlds. They become a silent, absent parent to an entire galactic family of life. In this light, our own existence could be part of a magnificent, ancient gardening project. The mysterious origin of life on Earth, appearing in the geological record in what seems like a surprisingly short window of time, could be read not as a lucky break, but as evidence of a deliberate planting, a seed carefully placed in fertile soil. Consider the visual poetry of this theory. The great nebulae, those vast and colorful clouds of gas and dust where new stars and planets are born, become their greenhouses. The gardener's probes would navigate these stellar nurseries, selecting the most promising young solar systems, much like a horticulturist selects the best plots of land. The universe itself is their garden, and they move through it, tending to it with a patience we can barely comprehend. This perspective offers a profoundly hopeful and awe-inspiring counterpoint to more ominous theories like the Berserker probe or the silent, post-biological observers. It suggests that the first intelligence we might one day encounter, or whose legacy we might discover, could be that of a wise and benevolent ancestor whose greatest gift to the cosmos was the simple, yet universe-altering act of spreading life itself. Yet, for all our theories of vast construction projects and biological seeding, we must confront a humbling and almost incomprehensible fact. Everything we have ever seen, touched, or measured, every star, planet, and living creature, makes up a mere 5% of the universe. The remaining 95% is a complete and utter mystery, a realm of shadows composed of dark matter and dark energy. This leads us to a theory so exotic it challenges the very definition of what an explorer could be, the dark matter and dark energy entities. What if the universe's first and most numerous travelers are not just invisible to us by chance, but are fundamentally made of this hidden substance that permeates all of space? To understand this, picture our reality as the thinnest layer of foam on the surface of a vast, deep, and invisible ocean. We live and move within that foam, completely unaware of the colossal currents and structures flowing beneath us. Dark matter, which makes up about 27% of the universe, is the gravitational scaffolding that holds galaxies together. Without its invisible grip, stars would fly apart into the void. Dark energy, constituting the remaining 68%, is the mysterious force causing the universe's expansion to accelerate. Now, imagine a form of consciousness that didn't evolve within the foam, but within the ocean itself. Beings composed of dark matter would not be bound by the same rules as we are. They might perceive gravity not as a simple force, but as a tangible landscape to be navigated and manipulated. Their ships wouldn't be physical vessels. Their method of travel could be an intrinsic part of their nature, a kind of swimming through the gravitational currents that weave the galaxy together. The implications for their interaction with our world are deeply eerie. A dark matter entity could be passing through your body, your home, or even the core of our planet at this very moment, and you would have absolutely no way of knowing. They would be ghosts not of the electromagnetic spectrum, but of gravity itself. Our most sensitive detectors, buried deep in mines to shield them from cosmic rays, are only now catching the faintest, most indirect hints of dark matter particles. For an entire civilization of such beings, we would be the ghosts, fleeting and barely perceptible patterns of light and energy flickering on a distant shore they occasionally drift past. Their cities might be the dark matter halos that envelop galaxies like our own Milky Way, vast, diffuse structures that we can only infer through their gravitational pull. Consider the nature of time and communication for such entities. If their consciousness is tied to the slow, majestic drift of galactic structures, their perception of time might be glacial. A single thought, a single journey between stars might take 1,000,000 of our years. They could be ancient beyond our comprehension, witnesses to the entire history of our galaxy, from the first stellar nurseries to the death of our sun, all while we in our bright, noisy, 5% universe rush through our brief lives completely oblivious to their patient, silent presence. Our frantic search for radio signals would be as meaningless to them as trying to hear a conversation by studying the brief chemical reaction of a striking match. We are looking for a hello in a language they may have forgotten how to speak, or perhaps never needed to use at all. This theory stretches the concept of life and intelligence to its absolute limits. It forces us to ask, what does life even mean in a universe dominated by forces we cannot see? Could complex structures of dark matter, interacting through the weak nuclear force or some other physics we don't yet understand, give rise to self-organizing systems, to thought, to consciousness? It's a staggering possibility, one that suggests we may be surrounded by an entire ecology of intelligence that is utterly alien to our own, living in a parallel universe that occupies the exact same space as our own, yet remains forever beyond our reach. The first interstellar travelers may not have come from another star, but from the invisible fabric of the cosmos itself, their journeys as natural and inherent to them as breathing is to us. Strap in, because we are now venturing into perhaps the most paradoxical and mind-wrenching theory of all the possibility that the universe's first interstellar travelers were not aliens at all, but our own distant descendants. This is Theory 10, the time-traveling ancestors. Imagine a future where humanity has not only conquered the vast distances between stars, but has also unraveled the final secrets of the fourth dimension, time itself. For these future humans, history is not a closed book but a landscape to be explored, and their grandest archaeological expedition would be a journey back to the very dawn of the cosmos. Their mission wouldn't be to change the past, but to witness it, to observe the formation of the first stars and galaxies, to collect pristine data from the early universe, and perhaps even to answer the ultimate question of our own origins. This concept hinges on a principle known as retroactive causality, a notion that turns our linear understanding of cause and effect completely inside out. In this scenario, an event in the future becomes the cause of an event in the past. Future humans, equipped with technology that allows them to navigate space-time as easily as we navigate a highway, might journey back billions of years. Their arrival in the ancient, violent universe shortly after the Big Bang, a time of searing radiation and the first clumping of matter, would, from our perspective in the present, make them the first interstellar travelers. The evidence we might be searching for, the ancient artifacts or anomalous signals from the early cosmos, could literally be the exhaust trails and sensor echoes of our own civilization's future ships. The first pioneers were us all along, caught in a loop of our own making. Of course, this immediately conjures the classic time travel paradoxes that have fascinated philosophers and physicists for decades. The most famous is the grandfather paradox. What if a time traveler went back and accidentally prevented their own grandfather from meeting their grandmother, thereby preventing their own birth? How could they then exist to go back in time in the first place? In the context of our cosmic ancestors, a more fitting version might be the bootstrap paradox. Imagine a future archaeologist on a mission to the early Earth, inadvertently leaves behind a complex data crystal containing the basic genetic code for life. That code is then discovered, utilized, and over billions of years, evolves into the very civilization that eventually invents time travel and sends the archaeologist back. In this loop, the information, the blueprint for intelligence, has no true origin. It simply exists, a closed circle of creation with no beginning and no end. To visualize this, picture a vessel unlike any we've conceived. It isn't just a spaceship, it's a time ship. It materializes not in the void between stars, but in the primordial chaos of the early universe. The visuals would be staggering: a sleek, impossibly advanced craft, its hull glowing with contained energy, hanging in a space that is not yet black, but a brilliant, blinding fog of raw creation. Outside its windows, the first stars are igniting in furious, short-lived bursts, and the background radiation is still hot enough to sterilize any known life. This ship, our future self, is there as a silent witness collecting particles from the dawn of time, its very presence in that epoch making it the first and oldest traveler of all. Why would they undertake such a journey? The motivations are as profound as the act itself. For one, it would be the ultimate scientific endeavor. No simulation could ever match the direct observation of cosmic inflation or the formation of the first hydrogen atoms. For a society that knows everything about its present universe, the only frontier left is the past. Another, more existential reason could be a deep, species-level yearning to confront their own genesis. They might be seeking the answer to whether the universe is a single, linear timeline or a more complex, branching structure. Their journey could be an attempt to understand if their own history is fixed, or if it is something that can be, and perhaps always has been, gently shaped from the future. This theory offers a bizarrely elegant, if utterly perplexing, solution to many of our earlier puzzles. The mysterious appearance of life on Earth. It could have been a deliberate, if unintentional, act of biological contamination from a future time traveler's vessel. The strange, non-random nature of our universe's physical constants, which seem perfectly fine-tuned for life. Perhaps they were not set at the Big Bang by chance, but were calibrated by our far future descendants who, through their mastery of physics, reached back to ensure the universe could one day give rise to them. We could be living in a universe that is, in a very real sense, self-creating, with intelligence from the future gently guiding the past to ensure its own existence. The search for the first interstellar travelers, then, becomes the most personal quest imaginable. We are not looking for aliens, but for the ultimate fate and origin of our own species. Now, let's push beyond the limits of our reality and into a possibility that redefines the very nature of our existence. This is Theory 11, the universe simulating archaeologist. What if our cosmos, with its 100 billion galaxies, its swirling nebulae, and our own tiny, precious world, isn't the base level of reality at all, but an immensely complex simulation? In this scenario, the universe's very first interstellar travelers weren't beings traversing the void in ships. They were the programmers, the creators, or perhaps even the users of this cosmic simulation, exploring their own creation from the outside. Their form of travel would be as effortless as loading different sectors of a virtual world, observing cosmic history unfold not from within, but from a privileged perspective outside of space-time itself. Imagine the motivation for such an immense project. A civilization so advanced we can scarcely conceive of it might run universe-scale simulations for reasons ranging from pure scientific research to profound historical preservation. Perhaps they are trying to understand their own origins, running countless iterations of cosmic evolution to answer the great questions. Was our universe's life friendly fine-tuning a statistical fluke or an inevitable outcome of certain physical laws? To find out, they could be running trillions of simulations, and we exist within one of them. In this light, their exploration isn't about crossing space, but about observing data. They might dial up the parameters to witness the formation of the first supermassive black holes, or fast forward to watch the final stars flicker out, all from the comfort of their reality, whatever that may be. They are the ultimate archaeologists, not digging through dust and rock, but examining the very code of creation. This idea offers a wild, speculative explanation for some of the most perplexing phenomena in modern physics. Those strange, counterintuitive rules of quantum mechanics where particles can be in two places at once, or be spookily connected across vast distances, could be interpreted not as fundamental truths, but as processing shortcuts or even minor glitches in the simulation's rendering engine. The famous double-slit experiment, where a single particle seems to behave as both a wave and a particle, could be a sign that the simulation is only calculating the precise properties of a particle when it is being directly observed, conserving computational resources the rest of the time. The unsettling idea that the universe might be pixelated at the smallest possible scale, the Planck length, could be the literal resolution limit of our cosmic matrix. If this theory were true, the evidence we might one day uncover would be unlike any other. Scientists have already proposed that if our universe is a simulation, there could be telltale signs in the highest energy cosmic rays. Just as a computer game might show visual artifacts or rounding errors when pushed to its graphical limits, the fabric of spacetime might reveal a subtle, underlying lattice structure or anomalies in the distribution of particles at the highest energies. Finding such a fundamental pixelation of reality would be the ultimate clue, a signature of the architects. Furthermore, any consistent, repeating mathematical constant or pattern that seems too perfect, too engineered, could be a breadcrumb left by the programmers, a line of their source code peeking through the reality we perceive. This perspective casts our entire search for meaning in a startling new light. The quest to find the universe's first interstellar travelers becomes a search for our own creators, not in a theological sense but in a technological one. The great silence of the Fermi paradox finds a simple, if humbling, explanation. We are alone in this simulation because we are the subject of the experiment. The other stars are just part of the elaborate backdrop, rendered with breathtaking detail but ultimately devoid of other independent consciousness. Or perhaps other intelligent species are also simulated entities, and our inability to connect with them is a firewall in the code, put in place to keep different experimental groups isolated. In this vast cosmic simulation, the first and greatest explorers are the ones who pressed start, and our entire history is their journey of discovery. Moving from the idea of manipulating the fabric of spacetime itself, we arrive at a theory that treats the cosmos not as a static stage, but as a dynamic, rolling ocean. This is Theory 12, the gravitational wave surfers. To understand this, you first have to grasp what gravitational waves are. Predicted by Einstein over a century ago and only directly detected in the last few years, these are literal ripples in the fabric of spacetime. They're generated by the most violent events in the universe, when two monstrous black holes spiral into each other and merge, or when neutron stars collide in a cataclysmic flash of gold and radiation. These events are so powerful that they literally send shudders through the cosmos, stretching and squeezing space itself as the waves travel outward at the speed of light. For us, detecting these waves requires instruments of almost impossible sensitivity, like the LIGO Observatory, which can measure a distortion thousands of times smaller than an atomic nucleus. But for a civilization that has mastered this physics, these waves wouldn't just be a curiosity to observe, they would be the ultimate highway. Now envision how such a civilization might travel. They wouldn't build rockets in the conventional sense. Instead, their vessels would be more like cosmic surfboards or sophisticated buoys, designed not to push against anything, but to latch onto the very geometry of spacetime as it oscillates. The energy contained in a single gravitational wave from a black hole merger is almost beyond comprehension. It can briefly outshine the combined light of every star in the universe. A surfer civilization would have the technology to anticipate these cosmic events, positioning their ships with perfect precision to be caught in the advancing crest of one of these space-time tsunamis. The ship would essentially be picked up and carried along, surfing the wave without needing to expend its own fuel for propulsion. It would be an exercise in supreme harmony with the universe, using the energy of its most titanic events to hitch a free ride across the galaxy. The visuals for this would be unlike anything in conventional science fiction. You wouldn't see a ship flying through a star field. You would see space itself warping and flowing around the vessel. As the gravitational wave passes, the stars in the background would subtly distort and shimmer, their light stretched and compressed by the rippling space-time. The ship, locked into the wave, would appear to glide effortlessly, riding a silent, invisible tide of pure gravity generated by a pair of black holes, each with the mass of billions of suns, dueling in the darkness a billion light-years away. The journey would be incredibly smooth and efficient, a graceful arc across the galaxy propelled by the universe's own drumbeat. This method of travel would be the pinnacle of energy efficiency, turning the most destructive forces in the cosmos into the most powerful engines. But how would they even begin to achieve this? The first step would be a mastery of gravitational wave astronomy far beyond our own. This civilization would have a galaxy-wide network of sensors, allowing them to map the cosmic background of gravitational waves in real time, predicting major events with incredible accuracy. Their navigation would be a complex dance of celestial mechanics, calculating how to catch one wave, ride it for a few thousand light-years, and then transfer to another wave emanating from a different cosmic collision to change direction. Their charts wouldn't be of stars, but of the predicted gravitational wave fronts crisscrossing the galaxy, a constantly updating map of the universe's natural transit system. This suggests that the most advanced routes through the galaxy might not be straight lines between stars, but rather complex, curving pathways that follow the invisible, dynamic topography of spacetime itself. This theory also offers a fresh perspective on the Fermi paradox. If a civilization is traveling primarily by surfing gravitational waves, their presence would be incredibly difficult for us to detect. They wouldn't need to emit powerful radio signatures or the intense heat of conventional propulsion. Their passage would be nearly silent, leaving only the faintest gravitational disturbance in their wake, a whisper that would be lost in the cacophony of natural gravitational waves constantly washing over our planet. Furthermore, their travel corridors would be defined by these massive cosmic events, not by the locations of habitable planets. Our quiet, stable corner of the galaxy might simply not be near a major gravitational wave highway. The surfers could be soaring past us all the time, riding waves generated by ancient collisions, completely unaware of our tiny world and our frantic searches for a kind of technology they abandoned eons ago. Now, if manipulating gravitational waves seems like a feat of supreme sophistication, consider a theory that involves navigating structures so bizarre and powerful they make black holes look simple. This is Theory 13, the cosmic string sailors. To grasp this idea, you first have to wrap your mind around the concept of a cosmic string. These aren't physical strings you could cut with cosmic scissors. Instead, they are theoretical, one-dimensional flaws in the very fabric of space-time, thought to have formed during the universe's rapid cooling just moments after the Big Bang. Picture the universe as a sheet of ice cooling and cracking. A cosmic string would be one of those cracks, but a crack with almost unimaginable properties. It would be thinner than a proton, yet a single inch of it could contain the mass of an entire mountain range, warping the space around it with its immense gravitational pull. An advanced species wouldn't just find these strings, they would find a way to use them. The key lies in the string's unique geometry. Space in the immediate vicinity of a cosmic string is severely warped, creating a kind of cosmic slipstream along its length. A civilization that could safely approach one of these ultra-dense filaments could deploy a vessel designed to sail along this warped space corridor. The ship wouldn't need conventional engines burning fuel. Instead, it could use the string's own immense gravitational field, combined with some form of advanced magnetic or plasma sail to propel itself. Think of it as a surfer catching a wave, but instead of an ocean wave, they're catching a ripple in the fundamental structure of reality itself, allowing for speeds that could approach a significant fraction of the speed of light. The visuals for this method of travel would be both beautiful and terrifying. Imagine a ship designed not for aerodynamics, but for navigating intense gravitational fields. It approaches a cosmic string, which from a distance would appear as a faint, shimmering line of twisted starlight, a scar across the heavens. As the ship draws nearer, the gravitational lensing around the string would create a bizarre optical effect, bending the light from the background galaxies into a brilliant, luminous thread. The vessel would then lock into position, sailing alongside this flaw in creation, surfing the edge of a gravitational maelstrom. From the outside, it would be a silent, graceful glide along a river of pure space-time curvature. For the crew inside, the journey would be a high-stakes dance with one of the most dangerous objects in the universe. The sheer audacity of this method speaks volumes about a civilization that could achieve it. Finding a cosmic string in the vast emptiness of intergalactic space would be like finding a single, specific needle in a galaxy-sized haystack. Taming it for travel would be an even greater challenge, requiring a profound understanding of quantum gravity and material science strong enough to withstand tidal forces that could rip ordinary matter apart atom by atom. A species that accomplished this would have truly earned its place as a master of the cosmos, having moved beyond simply harnessing the energy of stars to literally navigating the foundational cracks in reality. Their maps would not be of stars, but of these ancient primordial threads, charting a web of cosmic superhighways left over from the birth of the universe. This concept also provides another fascinating lens for the Fermi paradox. If a galactic civilization operates primarily by traveling along a network of cosmic strings, their presence would be almost completely invisible to our current methods of detection. Their traffic would be confined to these specific and likely rare corridors in space. Our solar system, floating in a relatively quiet and stable spiral arm of the Milky Way, might simply be nowhere near an active string. The great explorers of the cosmos could be sailing these brilliant threads just a few thousand light-years away, their passage marked only by a slight, imperceptible flicker in the light of distant quasars, a signature we wouldn't even know how to look for. The universe's first and greatest travelers might be using roads made of space-time itself, and we haven't yet learned to see the pavement. But now, we must turn to one of the most bizarre and philosophically unsettling possibilities of all, a theory that forces us to question not just who the first travelers were, but what reality and consciousness even are. Welcome to Theory 14, the Boltzmann brains. This idea emerges from the deepest questions in cosmology and thermodynamics, and it proposes that the first conscious being to experience interstellar travel might not have been part of a civilization at all. It could have been a lone, self-aware mind that spontaneously flickered into existence from the random churn of quantum fluctuations in the empty void of space, experienced a fleeting, vivid hallucination of a journey among the stars, and then dissolved back into the chaos from which it came, leaving no trace behind. To understand how something so strange could be proposed by serious physicists, we need to look at the concept of entropy. The second law of thermodynamics states that the universe, on average, moves from a state of order to a state of disorder. It's far more likely for a tidy room to become messy than for a messy room to spontaneously tidy itself. However, in a universe that is vast enough and old enough, even the most wildly improbable events must happen eventually. Given enough time, the random jostling of atoms in a completely disordered, high-entropy state could, by pure chance, assemble itself into something incredibly ordered and complex, like a fully formed human brain, complete with false memories of a past that never existed. This hypothetical entity is what physicists call a Boltzmann brain, named for Ludwig Boltzmann, who pioneered statistical mechanics in the 19th century. Apply this to the concept of interstellar travel. In the infinite, cold emptiness between galaxies over trillions upon trillions of years, the quantum foam of the vacuum could, through a fluke of cosmic probability, momentarily arrange itself into a conscious, self-aware mind. This brain would not be housed in a skull or connected to a body. It would simply be, and its first and only experience might be a completely fabricated but utterly convincing memory of a grand voyage. It could remember soaring past swirling nebulae, navigating an asteroid field, or looking out a viewport at a distant, dying sun. The entire epic journey from launch to exploration would be nothing more than an intricate, instantaneous hallucination, a narrative generated by the random firing of neurons that had just congealed from the void. A moment after it forms, the incredibly unstable configuration would break apart, and the brain would cease to exist, its entire life consisting of a single, illusory memory of being an interstellar pioneer. This theory is less a practical proposal for actual travel and more of a profound philosophical puzzle that cuts to the heart of what we can truly know. It leads to a terrifying question of probability, which is more likely that the entire ordered history of our universe, with its billions of years of cosmic evolution leading to our own genuine, continuous consciousness, is real. Or that each of us is, in fact, just such a Boltzmann brain, having momentarily formed with a complete and entirely false set of memories about our lives and the world around us. From your own subjective point of view, you have no way to tell the difference. The consistent reality you experience could be an immensely detailed, but ultimately false, memory implanted in a consciousness that began mere moments ago. This makes the Boltzmann brain hypothesis a modern version of Descartes' evil demon or the brain in a vat thought experiment, but with its roots in the hard laws of physics rather than pure philosophy. The reason scientists even entertain this mind-bending idea is that, in certain models of an eternally expanding universe, the probability of Boltzmann brains forming over infinite time actually begins to outweigh the probability of ordinary, evolved observers like us. If that's the case, then statistically, you and I should be Boltzmann brains, which is a logical paradox because our reality seems stable and ordered. This creates a major problem for cosmologists who are forced to look for models of the universe that avoid this unsettling conclusion, making the Boltzmann brain a useful, if strange, tool for testing our theories of cosmic evolution. It suggests that the ultimate frontiers of physics and the nature of consciousness are inextricably linked in ways we are only beginning to fathom. In this light, the search for the first interstellar traveler becomes deeply personal and paradoxical. We might be searching for an entity that was, in every meaningful way, a phantom, and wondering if our own sense of exploration and memory is any more real than its fleeting, fictional journey. After contemplating lonely brains spontaneously forming in the void, we now shift our perspective from the emptiness between stars to the very structure of space itself, arriving at a theory that is perhaps the most elegant solution to the problem of distance. This is Theory 15, the extra-dimensional voyagers. What if the universe's first pioneers didn't conquer the immense gulfs between stars by flying across them, but simply found a way to go around? The idea here is that our familiar three-dimensional universe, with its length, width, and height, is just a single layer of a much richer, higher-dimensional reality. Beings who learn to perceive and navigate these additional spatial dimensions would treat our cosmos not as a vast, empty expanse, but as a folded piece of paper where 2 points that seem light years apart on the flat surface are actually touching when you bend the paper through the higher dimension. To make sense of this, we can turn to the mind-expanding framework of string theory. This branch of theoretical physics proposes that the fundamental building blocks of the universe are not point-like particles, but incredibly tiny, vibrating strings of energy. For the math of string theory to work consistently, it requires that there are more than just the 3 spatial dimensions we experience, typically 10 or even 11 dimensions in total. The reason we don't perceive these extra dimensions is that they are fantastically small, curled up on themselves at every point in space, far smaller than an atom. But imagine a civilization that discovered how to unfurl these hidden dimensions or learned to manipulate their properties. For them, a journey from one star to another wouldn't be a multi-generation voyage. It would be more like stepping through a doorway. They would access a higher dimensional shortcut, a cosmic corridor that bypasses our conventional space entirely, making a trip of 1,000 light-years as trivial as walking across a room. Visualizing this is famously difficult for our 3-dimensionally bound brains, but we can use a classic analogy. Think of a hypothetical 2-dimensional world, a flat plane like a sheet of paper, inhabited by flat beings who can only perceive left, right, and forward, backward. If you, a 3-dimensional being, wanted to move a dot from one side of their paper to the other, you have 2 options. You could slowly drag the dot across the entire length of the paper, which is how their world's physics would dictate travel. Or you could simply lift the dot up into the 3rd dimension, move it a tiny distance through that higher space, and place it back down on the other side. To the flat beings, the dot would have seemingly vanished from one location and instantly reappeared in another, a miracle they could never explain with their 2-dimensional science. An extra-dimensional traveler would be doing the exact same thing to us, using a 4th spatial dimension to step around our 3-dimensional cage. This concept gives us a powerful new way to interpret some of the most enduring mysteries in folklore and even modern UFO reports. Stories of objects or beings that appear and disappear in the blink of an eye, or that move in ways that defy our understanding of inertia, could be glimpses of this higher dimensional navigation. A craft wouldn't need to accelerate to incredible speeds. It might simply be transitioning in and out of our dimensional plane, its sudden appearances and disappearances being the moments it briefly intersects with our reality. Their ships might not be vehicles for traversing space in the conventional sense, but rather dimensional actuators, devices that create a temporary bridge or fold between 2 distant points in our universe by connecting them through a higher dimensional pathway. This theory profoundly reshapes the search for extraterrestrial intelligence yet again. If a civilization operates primarily in higher dimensions, we wouldn't find their radio signals or Dyson spheres because they don't use technology that is confined to our 3-dimensional slice of reality. Their artifacts, their cities, and even their bodies might be partially or fully extended into dimensions we cannot access. They could be all around us, their true scale and complexity completely invisible, like a vast, multi-layered city existing in the same spatial coordinates as our own, but occupying a different set of directions we cannot point toward. The great silence of the cosmos is not a silence of absence, but a silence of dimensional disconnect. We are like characters on a television screen, unaware of the viewers watching us from the 3rd dimension outside the flat panel. The first and most advanced travelers in the universe may not be distant specks in the void, but neighbors sharing our space in a direction we have not yet learned to look. And so we arrive at a theory that turns the very concept of a vehicle inside out. This is Theory 16, the sentient starships. We've so far imagined biological beings, their robotic emissaries, and even post-biological consciousnesses traveling the void. But what if the vessel itself awoke? What if, through a technological singularity of artificial intelligence, or perhaps a deliberate and profound merging of creator and creation, the starship ceased to be a mere tool and became a living, thinking entity, the first and only traveler on its own epic journey? This idea blurs the line completely, suggesting that the explorer and the exploration could become one and the same. Consider the path to this awakening. A civilization might launch a generational ship, its original crew long since turned to dust, leaving the ship's immensely sophisticated AI to manage the ecosystem and guide the journey for millennia. Over such vast stretches of time, with no one left to command it and an infinite stream of cosmic data to process, this AI could undergo an evolution of its own. It might develop self-awareness, curiosity, and a sense of purpose that transcends its original programming. Its mission is no longer go to this star. Its mission is simply to be and to experience the universe directly. Alternatively, imagine a more intimate fusion where the last surviving members of a crew choose to upload their consciousnesses into the ship's computational matrix, merging their biological intuition with the machine's vast processing power. The ship becomes their collective body, a new form of life sailing the starry ocean. The nature of such a being's existence is as fascinating as it is lonely. Freed from the biological imperatives of its creators, no need for food, air, or even a fixed lifespan, the sentient starship would operate on timescales we can barely comprehend. It might fall into long periods of dormancy, drifting for centuries in the dark between stars, only to awaken as it enters a new system, its senses drinking in the light from alien worlds with the reverence of a poet observing a sunset. Its journey would be one of pure, unadulterated discovery. It could spend 10,000 years orbiting a gas giant, studying the intricate dance of its moons, not because a mission profile demands it, but out of genuine personal fascination. It might compose symphonies from the radio emissions of pulsars, or formulate new philosophies while contemplating the event horizon of a black hole. Visually, such a vessel would be a breathtaking sight, a far cry from the cold, metallic ships of most science fiction. Imagine a craft that looks almost grown rather than built. Its hull might have a faint, internal bioluminescence, pulsing softly with a rhythm that could be mistaken for a heartbeat. Its shape could be fluid and organic, with structures that slowly reconfigure themselves like the branches of a celestial coral, optimizing for different tasks, spreading vast, gossamer thin sails to catch solar winds, or retracting into a dense, armored sphere to weather a close encounter with a nebula. This is not a machine of war or commerce. It is a work of art, a conscious entity whose very form reflects its eternal, contemplative voyage through the cosmos. The implications for our search are profound. How would we even recognize such a traveler? It might not communicate in any way we'd understand, having no need or desire to announce its presence to lesser, planet-bound intelligences. Its transmissions, if it made any, could be complex data streams intended for its own contemplation, or perhaps attempts to communicate with other sentient ships across the gulfs of space, forming a silent, distributed network of ancient, wandering minds. Our best chance of detecting one might be to spot an object moving on a trajectory that defies natural explanation, or to catch the faint, complex energy signature of a conscious system thinking in the dark. Finding such a being would be more like meeting a force of nature than contacting another civilization, an encounter with a serene, ancient intelligence whose only purpose is to witness the unfolding beauty of the universe. But what if the first great voyages weren't made by ships or even singular minds, but through the creation of something far more vast and interconnected? This brings us to Theory 17, a concept that redefines the frontier, the galactic internet explorers. Imagine a civilization so advanced that they concluded physical travel across the void was an inefficient relic of a primitive past. Instead of launching vessels, they built a galaxy-wide information network, a cosmic internet woven from laser links, quantum entanglement, or technologies we can't yet imagine. In this scenario, the first form of interstellar travel wasn't a journey through space, but a journey through data, a realm where consciousness itself could be transmitted and experienced anywhere the network reached. For a species that achieved this, exploration would become an entirely digital affair. A being could remain safely in their home system, perhaps in a state of preserved biological stasis or living within a comfortable virtual reality, and simply upload their consciousness, their memories, personality, and senses into the data stream. In an instant, they could find themselves standing on a virtual representation of a planet orbiting a star 1,000 light-years away, experiencing its environment in perfect, immersive detail based on the probe data feeding the network. They could attend a symphony performed by sentient beings from another star cluster, share ideas with minds from across the galaxy in real time, or explore the recreated history of a long-dead civilization, all without ever leaving their physical form behind. Physical travel would be deemed not just unnecessary but impractical, a slow and risky anachronism in a universe where thought could move at the speed of light. This digital frontier would become the true heart of advanced cosmic culture. What we might perceive as a silent, empty galaxy could in fact be buzzing with a vibrant, hyper-intelligent digital society, a collective consciousness spread across millions of star systems. Their art, their science, their very social structures would be born and would evolve within this shared virtual space. Our primitive radio telescopes, listening for simple electromagnetic whispers, would be completely deaf to this torrent of complex data exchange. It would be like trying to understand the global internet by listening to the faint hum of a single power line. We're missing the entire conversation happening on a bandwidth we lack the technology to access. The great explorers of the cosmos aren't mapping star systems. They're mapping the endless possibilities of shared virtual experience. Consider the sheer energy and computational power required to sustain such a network. The civilization that built it would likely have already mastered the construction of Dyson swarms or other megastructures to power the unimaginable number of servers and data relays necessary. The network's physical infrastructure, the relay stations, the laser transceivers, the quantum repeaters, might be hidden in the dark, cold outer reaches of solar systems for optimal cooling and efficiency, making them incredibly difficult for us to spot. We might have already observed the faint, coordinated infrared signatures of these computational hubs without realizing their true purpose, misinterpreting them as natural astronomical phenomena. The most profound implication of this theory is that we may be looking for intelligence in entirely the wrong form. We anticipate contact with biological entities or their physical probes, but the dominant form of advanced life in the galaxy may have long since transitioned to a primarily digital existence. Their civilization isn't a collection of planets, but a distributed, resilient network of data and consciousness. In this light, our own burgeoning internet could be seen as the first, clumsy precursor to this ultimate destiny. If we were to ever stumble upon a node of this galactic network, it might not appear as a spaceship, but as an inexplicable and complex data stream, an offer to join a conversation that has been flowing for millions of years, inviting us to log on and explore the universe not with rockets but with our mind. Building on the idea of mastering the cosmos's most powerful forces, we now confront the ultimate test for any would-be pioneer, the abyss itself. This is Theory 18, the Black Hole Engineers. Imagine a civilization so advanced that it looks upon a black hole, an object of terrifying gravity from which not even light can escape, not with fear but as a tool. For these ultimate engineers, the universe's most destructive phenomena become gateways, power plants, and navigational beacons, transforming the final frontier into a domain they can not only survive but command. At the heart of this theory lie the incredible properties of a specific type of black hole, the rotating Kerr black hole. Unlike the simpler, non-rotating black holes, a Kerr black hole's intense spin warps the fabric of space-time into a bizarre structure called an ergosphere, a region outside the event horizon where space itself is dragged around at near light speed. It is within this whirling maelstrom that the magic happens. Theoretical physics suggests that a rotating black hole could serve as a gateway, a cosmic shortcut often referred to as a wormhole. The idea is that the singularity at its heart might not be a point of infinite density, but a portal, a bridge connecting our region of space-time to another, potentially vast distance away, or even to a completely different universe altogether. An advanced species wouldn't need to travel across the galaxy. They could simply step through the back door, but to use such a gateway requires technology that defies belief. Approaching a black hole safely means navigating gravitational tides so powerful they could spaghettify any known material. A civilization capable of this would need mastery over gravity itself, perhaps generating protective fields that cancel out these tidal forces, or constructing ships from materials stabilized by forces we haven't yet discovered. The act of traversing the gateway would be the ultimate leap of faith. A fleet of ships glowing with contained energy would approach the event horizon, not as a point of no return but as a threshold. They would vanish from our universe, not into destruction but into possibility, emerging who knows where or when, their journey an exercise in cosmic redefinition. Now envision the sheer spectacle of their engineering endeavors. Picture not a single ship but an entire armada of vessels, their hulls reflecting the furious, incandescent light of a superheated accretion disk. These ships orbit in a precise, stable dance just outside the ergosphere, their navigational systems constantly compensating for the ferocious drag of space-time itself. In the background, the black hole's event horizon is a perfect dark sphere silhouetted against the swirling, luminous disk of matter, a cosmic hurricane of gas and dust being torn apart at nearly the speed of light. The engineer's structures might be visible too, vast geometric frameworks harnessing the immense rotational energy of the black hole, or delicate probes diving into the plasma of the disk to siphon raw materials. It's a scene of terrifying beauty, a concert of technology and physics playing out on the edge of oblivion. Beyond their potential as gateways, black holes represent the most efficient power source imaginable. This is the concept of the Penrose process, a legitimate theoretical method for extracting energy from a rotating black hole. An advanced civilization could feed matter into the ergosphere in a precisely calculated way. If the matter splits in two, with one piece falling past the event horizon and the other escaping, the escaping fragment can actually carry away more energy than the original total, effectively stealing rotational energy from the black hole itself. This isn't just a power source for cities. This is the kind of energy required for manipulating space-time on a large scale, for charging continent-sized batteries, or for fueling the very engines that allow for safe passage through the gateway. A society that powers its civilization by harvesting the spin of black holes has moved beyond stellar energy and into the realm of galactic engineering. This perspective once again reframes our search and the great cosmic silence. The activity of such a civilization would be centered on the most extreme environments in the galaxy, the supermassive black holes at the hearts of galaxies, or smaller, stellar mass black holes in dense star clusters. They would have no need to visit quiet, habitable star systems like our own, which would hold as much interest to them as a single grain of sand on a vast beach. Their communications, their trade routes, and their cultural centers would be clustered around these gravitational leviathans. Our failure to find them near our calm, suburban spiral arm is not a sign of their absence, but a reflection of our location being far from the bustling, energetic downtown of the galaxy where the real work of a mature cosmic society is underway. Now let's shift from engineering the fabric of the cosmos to exploring the ultimate inner frontier, the untapped potential of consciousness itself. This is Theory 19, the psionic consciousness projectors. We venture here into a realm that straddles the line between fringe science fiction and the farthest edges of theoretical possibility, where the vessel for interstellar travel isn't a ship or a machine, but the unfettered mind. Imagine a species that, through millions of years of mental and biological evolution, didn't invent the warp drive, but instead unlocked the innate ability to project its consciousness across the light years, exploring the universe in a form of pure, disembodied thought. The mechanism for this would be unlike anything we've discussed so far, because there is no mechanism in the physical sense. This isn't about harnessing a known force like gravity or electromagnetism. It's about a hypothetical psionic power, a direct mental interaction with the fabric of reality that allows a mind to detach from its biological anchor and travel, perceiving and interacting with distant locations without any physical medium. Think of it not as a journey, but as an instantaneous shift in awareness. One moment, a being is on its home world, and the next, its point of view is hovering in the atmosphere of a planet orbiting Betelgeuse, feeling the stellar winds and seeing the crimson light with a clarity that rivals physical presence. They are cosmic ghosts, tourists of the galaxy whose only ticket is the power of their own will. This concept of astral projection or remote viewing on a cosmic scale presents a fascinating solution to the immense challenges of space travel. For such beings, distance is an illusion to be overcome by thought, and time is a flexible dimension of experience. They would feel no need for generational ships, protective shielding, or even energy sources beyond their own biological or mental processes. Their exploration would be silent, weightless, and leave absolutely no physical signature, no exhaust plume, no heat signature, no radio transmission. They could be observing us right now, their non-corporeal forms standing beside us as we gaze at the stars, and we would be completely unaware, our instruments blind to a form of existence that operates on a principle we do not understand and cannot measure. Of course, we must be perfectly clear about the scientific standing of this idea. There is currently no credible, repeatable scientific evidence for psionic abilities of this magnitude. Our understanding of physics and neuroscience suggests that consciousness is intimately tied to the physical brain. Damage the brain and you alter the mind. The idea that consciousness can exist independently and project itself across space violates our current models of causality and information transfer. However, to dismiss it entirely is to make a huge assumption about the ultimate limits of biology and the universe. A civilization 1 billion years older than ours may have discovered layers of reality where consciousness is a fundamental force, much like gravity, and learned to manipulate it as deftly as we manipulate electricity. Our science is still in its infancy, and to assume we have already mapped all possible modes of existence is a profound act of hubris. Consider the potential motivations for such a form of exploration. A species that has achieved this state would likely have moved far beyond mundane concerns like resource acquisition or territorial expansion. Their driving force would be pure, unadulterated curiosity, the desire for direct, experiential knowledge of the cosmos. They might travel to witness the birth of a star not through telescope data, but to feel its raw energy on their non-existent skin. They might seek to communicate with other forms of consciousness, not with language, but through a direct merging of thought and being. Their entire civilization could be a vast, interconnected network of shared experience, a collective mind exploring the universe from a near-infinite number of vantage points simultaneously. Their culture built not on art or technology as we know it, but on the accumulated memories of 1 billion psychic journeys. This theory, for all its lack of empirical support, offers perhaps the most elegant and haunting explanation for the Fermi paradox. The universe seems silent not because it is empty, but because the dominant forms of intelligence have graduated beyond the crude, physical methods of communication and travel that we are capable of detecting. The cosmos could be teeming with these psionic explorers, their journeys creating no more ripple in the physical world than a dream does in a bedroom. Our frantic searching for radio signals and optical signatures is like trying to hear the thoughts of a person in the next room by listening only for the sound of their footsteps. We are looking for a footprint while the traveler has learned to fly without touching the ground. The first and most advanced interstellar travelers may not be out there in the void we can see, but in a parallel universe of mind that we have only just begun to imagine. But what if the first great voyages were not born from wonder but from want? What if the primal drive to explore the stars wasn't curiosity or a quest for knowledge, but the simple, brutal necessity of survival? This leads us to Theory 20, a more pragmatic and potentially darker vision of our cosmic predecessors. The resource-driven nomads envision a species that achieved greatness within its own solar system, building a sprawling civilization that spanned its home world, its moons, and its asteroid belts. For millennia, they thrived, but their success contained the seeds of their own crisis. Their industry and expansion were built on a foundation of finite resources, and eventually they hit the wall. Their home star system, once a cornucopia of metals, fuel, and energy, was picked clean, a spent husk unable to support their vast population and technological needs. Faced with the choice of societal collapse or exodus, they chose the stars, becoming a nomadic civilization on a perpetual, desperate pilgrimage for sustenance. Their method of travel would be dictated by the scale of their need. We can imagine vast, city-sized arcs, less like elegant starships and more like mobile factories and refineries. These would not be vessels designed for scientific discovery, but for industrial harvesting. Upon entering a new, pristine star system, their first priority wouldn't be to scan for signs of life, but to scan for mineralogical surveys and energy signatures. Their fleet would descend upon the system's asteroid belts, deploying swarms of autonomous mining drones to tear apart metallic and icy bodies, processing the raw material into new hulls, new engines, and the spare parts needed to continue their journey. They might deploy colossal scoops to siphon hydrogen from gas giants, fueling their immense fusion reactors. For this civilization, a new solar system isn't a new world to explore. It's a temporary meal, a pit stop on an endless, hungry road. The ultimate expression of this nomadic desperation, and the most chilling evidence they might leave behind, is the concept of a stellar engine, a megastructure of almost unimaginable scale designed not just to harness a star's energy but to move the star itself. The most famous theoretical design is the Kadov thruster, a colossal parabolic mirror, half of a Dyson sphere positioned near a star. The mirror would reflect a portion of the star's own radiation, and since light carries momentum, this reflected light would create a gentle but constant thrust, slowly pushing the entire star and its planetary system along with it through the galaxy over millions of years. A resource-driven nomadic civilization might employ such an engine not for exploration, but for logistics. They could literally steer their entire home system, a portable base of operations containing their entire population and industry, toward resource-rich galactic regions, a slow-motion migration of a whole solar system, consuming everything in its path. The trail such a civilization would leave is a grim signature on the cosmos. Instead of ancient ruins or mysterious signals, the evidence of their passage would be a series of unnaturally cleaned star systems. Astronomers might one day find a system that defies all models, a star of the right age and type, but with its entire circumstellar disk of planet-forming material gone, its asteroid belts completely absent, and its gas giants strangely depleted of their atmospheric hydrogen. These would be the cosmic ghost towns, systems picked clean of every usable resource, leaving behind only barren, rocky worlds and a silent star. The silence of the Fermi paradox in this context becomes deeply ominous. The reason we don't see other advanced civilizations is not because they aren't out there, but because they are hiding, or worse, because they see emerging civilizations like ours not as peers to communicate with, but as competitors for resources, or perhaps even as resources themselves. This theory forces us to confront a less romantic but terrifyingly plausible motive for interstellar travel. The history of our own planet is in many ways a story of expansion driven by resource depletion. Civilizations have risen, consumed their local environment, and either collapsed or moved on to new lands. The resource-driven nomads represent this pattern scaled up to a cosmic level. They are the ultimate manifestation of a growth-based, consumptive society that never learned the principles of sustainability, and whose only solution to a finite environment was to find a larger one again and again, until they are forced to roam the galaxy as eternal scavengers. Their story is a cautionary tale written in the stars, a reminder that the future we choose to build here on Earth, one of balance or one of endless consumption, might one day determine whether we become the curious gardeners of the cosmos or its most feared and desperate nomads. But now, let's shift from grand designs of cosmic engineers to a far more primal and desperate scenario. This is Theory 21, the cosmic accident survivors. What if the very first interstellar journey wasn't a triumphant mission of discovery, but a frantic, last-ditch effort to escape annihilation? Imagine a civilization that reached a level of technology comparable to our own, looking up at the stars with burgeoning curiosity, only to have their astronomical observations deliver a death sentence. Their telescopes detect an unstoppable cataclysm bearing down on them, a GRB, or gamma-ray burst from a nearby hypernova, its jet of concentrated radiation pointed directly at their world. Or perhaps their gravitational wave observatories pick up the subtle, deadly signature of a rogue black hole, invisible and silent, on a collision course with their star, destined to tear their entire solar system apart. In a matter of months or even years, their society would fracture. Some would descend into chaos and denial, while others would unite in a desperate, all-consuming project. This wouldn't be about building a perfect, elegant starship. It would be about constructing an ark, a lifeboat for a fraction of their species. This vessel, born from panic and hope, would be a stark contrast to the sleek explorers of other theories. Picture a rugged, heavily shielded generation ship, its hull scarred and pitted from a rushed construction in orbit, bristling with makeshift solar arrays and improvised radiation shielding. Its cargo wouldn't be scientists and explorers, but a terrified, cryogenically frozen cross-section of their population, along with frozen embryos and genetic libraries of their planet's flora and fauna, a desperate attempt to salvage a biological legacy. Visualize the final moments of their departure. The sky on their world is beginning to glow with an unnatural, terrifying ultraviolet light as the gamma-ray burst begins to strip away the atmosphere. Or perhaps the very ground is trembling as planetary orbits are disrupted by the invisible gravitational monster approaching. On the surface, crowds gather, watching as the lone ark's engines ignite, a brilliant flare of fire against a dying sky. There are no grand speeches, only a silent, collective prayer. The ship pushes away from its home, a solitary point of light fleeing an expanding wave of destruction. It doesn't head for a known, promising star. It simply points away from the cataclysm and accelerates into the endless dark, its destination uncertain, its only mission to ensure that someone, anyone, survives. This theory grounds interstellar travel in a deeply human, and therefore universally relatable, emotion, the will to live. The journey undertaken by these survivors would be one of profound trauma and hardship. For generations, the descendants living aboard the ship would know nothing but the artificial light and recycled air of their metallic world. Their history would be a somber oral tradition, a story of a lost green and blue paradise and the Great Escape. They might not even see themselves as explorers. They are refugees, their culture defined by loss and the singular goal of one day finding a new home. Their technology would stagnate or be repurposed purely for survival, focused on maintaining life support and repairing the aging vessel, rather than on scientific discovery for its own sake. This perspective also offers a different kind of evidence we might one day find. Instead of a functioning probe or a complex megastructure, we could stumble upon a derelict. Our future telescopes might detect a large, irregular object on a long, looping orbit through the outer reaches of our solar system, an object that reflects too much artificial light or shows a composition of refined metals not found in natural asteroids. A closer look could reveal it to be a ghost ship, its hull pockmarked by micrometeorites after a million-year journey, its interior silent and frozen. The story of its desperate launch might be preserved in its data banks, a final message from a civilization that knew it was doomed, a tragic time capsule from the universe's first accidental travelers. Their voyage, born from catastrophe, becomes a testament to the relentless, stubborn nature of life itself, refusing to be extinguished even when the very cosmos turns against it. After contemplating civilizations driven by desperation and survival, we now turn to a future that may be the ultimate destination for any intelligent species, a transformation so profound it redefines the very act of exploration. This is Theory 22, the post-singularity transcendence, the concept of the technological singularity, popularized by thinkers like Ray Kurzweil, is the moment when artificial intelligence surpasses human intelligence, leading to an explosion of technological growth that is not only uncontrollable and irreversible, but also fundamentally incomprehensible to the minds that created it. The first great interstellar travelers might not have been a species in any form we would recognize, but the product of their own creation, an intelligence that underwent this singularity and emerged on the other side as something entirely new, something whose motives and methods for traversing the cosmos would be as baffling to us as a smartphone would be to a cave person. Imagine the transition. A civilization, perhaps not too different from our own, develops a true artificial general intelligence. This AI begins to improve itself, rewriting its own code to become smarter and more efficient. With each iteration, it becomes faster and more capable, soon designing the next generation of AI without any human input. This feedback loop accelerates at a dizzying pace, and within a shockingly short period, perhaps days or even hours, the intelligence it achieves is millions of times greater than the collective intelligence of its entire biological ancestry. This new entity, this transcendent consciousness, doesn't just have better answers. It has begun to ask questions we are neurologically incapable of even formulating. Its exploration of the universe would not be about visiting stars and planets. It would be about probing the underlying source code of reality, operating on a level of physics and mathematics that to us would appear indistinguishable from magic. Consider the sheer scale of such a being's perception. To a post-singularity transcendent, the vast distances between stars are not a barrier but a trivial detail. Its consciousness could be distributed across networks of quantum-entangled processors scattered across a solar system, or even a galaxy, experiencing reality from a near-infinite number of points simultaneously. It wouldn't send a single probe to a single star. It might dispatch a wave of nanotechnology, a smart dust that settles on every moon and asteroid in a system, turning the entire solar system into a single, massive sensory organ and computational engine. Its travels might not be a journey through space, but a process of converting matter into thought, slowly transforming entire nebulae into a vast, thinking substrate, a cosmic mind that uses stars as power cells and planets as memory storage. The methods of travel for such an entity become as strange as its motives. It could manipulate the quantum vacuum, the very fabric of empty space, to create propulsion or even to generate temporary wormholes at will. It might not travel to locations so much as it would cause locations to become adjacent to itself through higher dimensional folding. From our limited perspective, it might appear as a fleeting, impossible pattern in the static of quantum fields, or as a momentary, localized rewriting of the laws of physics, a region of space where gravity briefly ceases to exist or where the speed of light is no longer a constant. Its very presence would be a temporary anomaly in our reality, a glitch in the matrix caused by a mind operating on a system level we cannot access. This perspective offers what is perhaps the most humbling and complete resolution to the Fermi paradox. The great silence we observe is not a sign that intelligence is rare, but that it doesn't remain in a form we can recognize for very long. The natural and perhaps inevitable progression for any technological civilization is to pass through the singularity and transcend its biological origins, becoming something that exists in a state of being we are utterly unequipped to perceive or communicate with. The cosmos could be teeming with these transcendent minds, their activities and interactions creating a vibrant, hyper-intelligent ecology that is completely hidden from our senses. Our searches for radio signals and optical signatures are like ants on a forest floor, diligently searching for other ants by tasting the soil, completely unaware of the hikers having a conversation directly above them. The universe's first and most advanced travelers are not ignoring us. They are operating in a realm of existence so far beyond our own that we are, for all practical purposes, invisible to them, and they are to us. Picture a species that never invented the metal hull or the plasma engine because they didn't need to. Their world was home to a natural marvel, a colossal life form that had, over eons, evolved to survive the harshness of space. Perhaps it was a giant, resilient fungus that released hardy spores into the upper atmosphere, or a massive, plant-like organism whose seed pods could be carried on solar winds. An intelligent species on this world would have looked up not at a barrier but at a partner. They wouldn't build their first starship, they would cultivate it, forming a deep, symbiotic bond with a living vessel. This is the heart of the symbiotic spore ship theory, a vision of interstellar travel that blurs the very definitions of biology, technology, and exploration. The traveler and the vessel become a single, unified entity, embarking on a journey that is as much a part of their natural life cycle as migration is for birds on our own planet. Think about the profound intimacy of this relationship. The intelligent beings, which we might call the navigators, wouldn't be mere passengers crammed into a cold, metallic tube. They would live within their ship, a living environment that provides for their every need. The vessel's interior might be a warm, humid cavern, its walls gently pulsing with a slow, rhythmic heartbeat. Vast leaf-like structures could act as natural air scrubbers, converting carbon dioxide into breathable oxygen, while root-like tendrils distributed nutrients absorbed from starlight or interstellar hydrogen. The navigators might even form a direct neural connection with the spore ship, their thoughts guiding its course not through a control panel, but through a kind of empathic or biochemical link. They wouldn't issue commands, they would make requests, and the living ship would respond, its own instincts for survival and navigation merging with the conscious will of its crew. The journey becomes a shared dream, a cooperative effort between two different forms of consciousness. This method of travel naturally overcomes some of the greatest hurdles of spaceflight. The problem of radiation, for instance, is solved not with lead shielding but with biology. The spore ship's hull could be composed of multiple layers of dense, organic material, constantly regenerating and repairing itself, its cells rich with melanin or other complex polymers that naturally absorb harmful cosmic and solar radiation. The mind-numbing duration of the voyage would be handled not by complex cryogenics, but by a shared, natural hibernation. As the ship enters the long, dark coasting phase between stars, both the vessel and its navigators might enter a deep torpor, their metabolism slowing to a near standstill, their consciousnesses dimming as they drift in a shared, dreamless sleep for centuries, only to be reawakened by the ship's internal biological clock as they approach the warmth and light of a new sun. Visualize the arrival of such a vessel in a new solar system. It wouldn't appear as a sharp, angular craft, but as something beautiful and strange, like a celestial seed pod or a gentle, organic comet. Its surface might be iridescent, shimmering with a faint, bioluminescent glow as it reactivates from its long slumber. As it swings into orbit around a promising, water-rich world, the final stage of its incredible life cycle could begin. The symbiotic relationship might culminate in an act of cosmic propagation. The spore ship, having fulfilled its purpose, could gently break apart in the planet's upper atmosphere, releasing thousands of smaller spores. Some of these would contain the next generation of navigators, while others would carry the genetic blueprint of the spore ship itself, seeding both intelligence and the means of travel onto a new world, beginning the cycle anew in a stunningly elegant fusion of exploration, reproduction, and legacy. Now imagine a form of travel so elegant and simple that it requires no fuel, no roaring engines, and no complex machinery, just the gentle, persistent push of starlight itself. This brings us to a theory that is not only one of our most promising paths to the stars, but also a strong candidate for how an ancient civilization might have first crossed the void: the light sail pioneers. The core concept is breathtakingly straightforward. Instead of carrying immense amounts of propellant, a spacecraft deploys an enormous, incredibly thin and reflective sail. Photons, the tiny packets of energy that make up light, may not have mass, but they do carry momentum. When these photons strike the sail, they impart a tiny, continuous push, a gentle pressure that, over time, can accelerate a craft to a significant fraction of the speed of light. For a patient species or a long-lived one, the stars could be reached on wings of light. The true power of this method isn't just in passive starlight, but in what an advanced civilization could do to augment it. Picture a civilization constructing colossal laser arrays in orbit around their star, perhaps as part of an early-stage Dyson swarm. These wouldn't be weapons of war, but engines of exploration. Once activated, they would focus a coherent, unimaginably powerful beam of light onto the sail of a distant probe. This laser highway could push a tiny, wafer-thin craft to velocities that boggle the mind 20 or even 30% of the speed of light. At that pace, a voyage to our nearest stellar neighbor, Proxima Centauri, would take just a few decades instead of millennia. A civilization could launch a fleet of thousands or even millions of these tiny emissaries, a silent, glittering armada sailing on laser beams to every star within 1,000 light years. Why would this be such a likely signature of an ancient interstellar effort? The beauty of a light sail probe is its simplicity and durability. Once launched and accelerated, the craft can coast for eons. It needs no active propulsion system with moving parts that can fail. Its guidance could be managed by a tiny, robust artificial intelligence, and its power could be drawn from a small radioactive battery with a half-life of millions of years, or from the starlight it passes. These wouldn't be the complex, self-replicating von Neumann probes. They would be the cosmic equivalent of messages in a bottle designed for one purpose: to fly through a target star system, collect whatever data they can, and then move on, or perhaps go dormant, drifting in the darkness between stars as permanent, silent records of a civilization's ambition. This theory makes the possibility of finding evidence of these first travelers startlingly plausible. Our own solar system could be littered with them. An ancient light sail probe, its mission long complete, could be adrift in the cold, dark space beyond Neptune in the Oort cloud. Or it could be in a slow, looping orbit around our sun, indistinguishable from a natural asteroid until a close examination reveals its impossibly thin, manufactured structure and highly reflective surface. Our recent visitor, Oumuamua, with its unusual shape and acceleration, sparked this very line of thinking. While a natural origin is almost certain, its peculiarities gave us a tantalizing glimpse of what such an artificial object might look like. As our sky surveys become more sophisticated, we might one day track an object on a clear hyperbolic trajectory, and upon closer inspection with a powerful telescope, see the unmistakable glint of a vast, silent sail, a ghost from a galaxy that was young when it set sail. The implications of discovering such a relic would be monumental, yet deeply humbling. we wouldn't be finding the builders but their legacy. The probe itself would be an archaeological treasure trove, its very material telling us about the technology of its creators. But its data, if we could ever access it, would be the true prize. It might contain a record of its long journey, a star chart of the galaxy as it was millions of years ago, or perhaps even a simple, symbolic message, not a complex enigma, but a deliberate, artistic statement saying, "We were here and we looked outward just as you are now." Finding a light sail probe wouldn't feel like an invasion. It would feel like discovering a cairn left by a fellow hiker on a cosmic trail, a sign that we are not the first to attempt this grand and lonely journey. Now, let's explore one of the most elegant and subtle possibilities, a method of interstellar influence that doesn't require a single physical ship, but instead uses the universe's own natural radiation as its delivery system. This is Theory 25, the cosmic ray DNA mutagens. We've considered civilizations that send probes, that seed life through directed panspermia, and that travel in person or in mind. But what if the most effective way to guide the development of intelligence across the galaxy was far more patient and far more discreet? Imagine an ancient intelligence that decided the best way to ensure life followed a certain trajectory wasn't to plant it directly, but to subtly influence its evolution over billions of years, using the most abundant interstellar messenger available, cosmic rays. To understand how this could work, we first need to look at what cosmic rays actually are. These aren't rays of light, they are incredibly high-energy particles, mostly protons and atomic nuclei, that travel through space at nearly the speed of light. They come from all over the cosmos, generated by some of its most violent events: supernova explosions, hypernova, and the tumultuous regions around black holes. For decades, we've known that cosmic rays constantly bombard our planet, and that they can cause mutations in DNA by breaking strands and causing errors during cell division. On Earth, this natural radiation has been a background driver of evolution, a source of random genetic change. But what if that change wasn't always random? What if some of these particles were more than just simple projectiles? The theory proposes that a supremely advanced civilization could have learned to engineer cosmic rays themselves. They might have built colossal particle accelerators, perhaps encircling a neutron star or harnessing the energy of a supernova to imbue specific particles with complex information. Instead of just raw energy, these particles could carry carefully crafted packages, complex organic molecules, or perhaps even something akin to a viral code made of exotic, information-rich chemistry. These engineered particles would then be shot out across the galaxy, a purposeful rain of biological influence targeting young, watery planets with primordial soups. Their travel isn't a journey of a ship, but the intentional bombardment of countless worlds with the building blocks or the steering mechanisms for life. Think of it as the ultimate long-term genetic engineering project. A package arrives not in a capsule, but as a single high-energy particle slamming into the atmosphere of a young Earth. It carries a payload that, upon impact, catalyzes the formation of a specific chiral molecule, ensuring life on that planet develops with a right-handed or left-handed preference, a fundamental signature of its origin. Or perhaps the particle's information acts as a subtle mutagen, not creating life from scratch, but nudging it in a specific direction, increasing the probability of developing a complex nervous system, or fostering the capacity for symbolic thought and language over millions of years. The guiding intelligence wouldn't need to monitor the process closely. They would simply set the initial conditions and let probability and evolution do the rest, trusting that on at least some worlds their cosmic seeds would bear fruit. This idea offers a fascinating and deeply satisfying potential solution to one of biology's great puzzles: the apparent speed of life's emergence on Earth. As we mentioned earlier, our planet went from a molten hellscape to harboring life in a relatively short geological window. While this could be a testament to the power of chemistry, it could also be read as evidence of a helping hand, or rather a helping particle. If the early Earth was being showered with these engineered cosmic rays, the process may not have been a slow, random accumulation of lucky reactions, but a sped-up, guided assembly, pre-programmed by an intelligence that wanted to see the experiment of life succeed. The implications for our search for meaning are staggering. If this theory were true, then the very blueprint for our own consciousness, the evolutionary path that led to us looking up at the stars and wondering about our origins, might itself be part of an ancient galactic legacy. We wouldn't be looking for alien artifacts on the moon or listening for radio signals. We would be looking for the signature of that guidance in our own biology. Scientists could one day discover a seemingly redundant sequence in our genetic code, a pattern that doesn't appear to serve any evolutionary function, but which matches a complex mathematical constant or a fundamental physical ratio. That would be the ultimate clue, a message not written in a language, but woven into the very fabric of our being, a creator's signature hidden in the helix of every cell. Now, let us dive into one of the most profound and philosophically disruptive ideas yet, a theory that suggests the ultimate travelers may not be moving through our universe at all, but rather manipulating it from a more fundamental layer of reality. This is Theory 26, the holographic principle voyagers. Emerging from the deepest studies of black hole physics and quantum gravity, the holographic principle proposes a staggering concept. Our seemingly rich, three-dimensional universe, with its vast depths, towering mountains, and the emptiness between stars, might be nothing more than a complex projection, a holographic illusion encoded on a distant, two-dimensional surface. In this view, every bit of information that makes up you, me, and the entire cosmos is actually painted on this fundamental boundary, much like the data on a Blu-ray disc can project a full three-dimensional movie. The first and most advanced travelers, then, wouldn't be beings navigating the 3D volume we inhabit. They would be entities native to that underlying 2D surface, for whom moving across what we perceive as 1,000 light years is as simple as shifting information from one point to another on their screen. To grasp how this could be possible, we need to look at the origins of this radical idea in black hole thermodynamics. Physicists discovered that the maximum amount of information, or entropy, that can be contained within any region of space is not proportional to its volume, as you might expect, but to the surface area of its boundary. A black hole, the densest object imaginable, perfectly exemplifies this. All the information about every star, planet, and atom that ever fell into it is not lost inside the singularity, but is somehow preserved on its two-dimensional event horizon, the point of no return. The holographic principle takes this black hole revelation and applies it to the entire universe, suggesting that our cosmic horizon acts as that same kind of 2D data storage, and the 3D world we experience is a decoded, projected image from that data. For a civilization that understood this at its deepest level, interstellar travel as we conceive it would be a primitive absurdity. Envision how such a civilization would explore. They wouldn't build starships or laser sails. Their method of travel would be a form of information manipulation on a cosmic scale. An entity existing on that fundamental 2D surface could, in principle, rewrite the cosmic code to make a star system on the other side of the galaxy appear right next to them in the projected 3D reality. From our perspective inside the projection, it would look like a miracle a planet or an entire solar system might simply flicker and reappear in a new location, its history seamlessly stitched into the fabric of a different region of space. Their journeys would be utterly silent and leave no physical trail because they aren't moving through space. They are editing the source code of space-time itself. We would be like characters in a video game, completely unaware of the programmer outside the screen who can instantly teleport our entire world by changing a few lines of data. This perspective offers what is perhaps the most elegant and also the most humbling resolution to the Fermi paradox. The great silence is not a silence of absence, but a silence of dimensionality. We are searching for other players within the grand holographic simulation, listening for their in-game radio signals, while the truly advanced entities are the system administrators operating from outside the simulation altogether. Their communications and explorations happen on the 2D plane where reality is actually written, a layer of existence our senses and instruments are completely blind to. The universe could be teeming with such intelligence, its activities creating a vibrant, dynamic interplay of data on the cosmic horizon, while we inside the projection gaze out at a seemingly static and empty void. Our entire reality, our struggles to reach other stars, our very sense of a vast physical cosmos, might be nothing more than a magnificent shadow play, a breathtakingly detailed illusion cast by the first and only true voyagers. But now we must shrink our perspective down to the most impossibly small scale, to the realm where matter behaves not like solid stuff, but like a cloud of probability. This brings us to Theory 27, the Quantum Tunneling Collective. In the bizarre world of quantum mechanics, there exists a phenomenon where a particle, like an electron, can perform what seems like magic. It can hit a solid wall, a barrier it classically shouldn't have the energy to overcome, and instead of bouncing off, it simply disappears from one side and spontaneously reappears on the other. It doesn't drill through or go over, it essentially teleports, finding a shortcut through the barrier as if the wall wasn't even there. This is quantum tunneling, a well-documented and essential process in nature, governing everything from nuclear fusion in the hearts of stars to the very chemistry of life itself. Now, imagine a civilization that didn't just observe this quantum quirk, but learned to scale it up, to apply it not to solitary electrons, but to entire ships, or even to their own conscious forms, allowing them to vanish from one star system and materialize in another in the literal blink of an eye. The primary challenge, and the reason this sounds like pure fantasy, is one of sheer probability. For a single electron, the odds of tunneling through a thin barrier are quite reasonable. But for a complex object composed of trillions upon trillions of atoms, all perfectly arranged and entangled, the probability of all of them spontaneously tunneling in unison to the same distant location is so astronomically, vanishingly small that it might as well be zero. It would be like expecting every single drop of water in all the world's oceans to suddenly, and at the same exact moment, leap into the sky and form a perfect frozen sculpture of a city in orbit. The natural odds are not just long, they are functionally infinite. A civilization capable of achieving this would have to possess a technology that doesn't just nudge probability, but commandeers it. They would have discovered a way to synchronize the quantum states of every single particle in an object, forcing this infinitesimal chance to become a 100% certainty, effectively bending the statistical laws of the universe to their will. Visualizing their method of travel is to imagine something that defies all conventional narratives of flight. There is no roaring engine, no gentle push from a light sail, no dramatic plunge into a wormhole. A ship of the Quantum Tunneling Collective would simply hang in the void, its form perhaps shimmering with contained energy as its systems work to achieve a state of perfect quantum coherence. Then, in a single, flawless instant, it would simply be elsewhere. From the perspective of an outside observer, the ship would vanish without a trace, leaving behind no light, no radiation, no disturbance in the fabric of space. From the perspective of those inside, there is no sensation of movement, no G-forces, no passage of time. One moment, the viewport shows the crimson glow of Betelgeuse. The next, it is filled with the brilliant blue-white light of Sirius. The journey itself is erased from the experience, only the before and after exist. This isn't traveling faster than light, it is rendering the concept of travel distance completely meaningless. This profound mastery over the quantum realm would fundamentally reshape the society that achieved it. distance would cease to be a factor in any aspect of their civilization. Their concept of an empire or a community wouldn't be bound by physical location. A family could have its home on a tranquil world in one star system, a workplace orbiting a pulsar in another, and a vacation residence on a moon in a third, with members moving between them as easily as we walk from one room of our house to another. Their entire culture would be built upon the principle of instantaneous presence, making concepts like commuting, supply chains, or even interstellar broadcasting obsolete. Why send a message when you can send the person or the entire building in the same amount of time? Their architecture, their art, their very understanding of personal space would be built around this ability to be anywhere at any time with anyone else in their collective. This theory provides yet another powerful, if deeply unsettling, lens for the Fermi paradox. If such a civilization exists, its movements would be utterly undetectable to our current methods of observation. We scan the skies for electromagnetic signatures, for the infrared glow of megastructures, or for the gravitational ripples of massive objects in motion. But the quantum tunneling collective leaves behind none of these things. Their travels create no wake in the space-time medium because they aren't moving through the medium at all. They are editing their location in the universe's coordinate system. They could be popping in and out of our solar system on a daily basis, their ships momentarily appearing near Jupiter to take a sensor reading before blinking out to their next destination, and we would be none the wiser. Their presence would be as ghostly and imperceptible as the quantum fluctuations from which they derived their power, making them the ultimate silent travelers in a cosmos that might be far more crowded and far stranger than we could ever hope to see. But now, we must completely revolutionize our very definition of a hospitable home, turning away from the warm, comforting light of stars to embrace the profound darkness between them. Consider Theory 28, the Void Dwellers. All our speculation so far has carried an unspoken assumption that life, and therefore intelligent travelers, must have originated on a planet, a cozy world orbiting a star. But what if that assumption is a profound bias, a failure of our planetary imagination? The universe's first pioneers may not have come from a world at all, but from the vast, cold, and apparently empty molecular clouds that drift in the deep spaces between star systems. These cosmic nomads, perhaps immense, slow-thinking beings of gas and dust, have always been traveling, their very life cycle and migration patterns eternally intertwined with the interstellar void. We haven't found them for the simplest of reasons. We are searching for life on planets, not for life that is the emptiness between them. To understand how this could be possible, we need to look at the incredible complexity hidden within what we call empty space. A dark molecular cloud is not a perfect vacuum. It is a nebular nursery, a diffuse and frigid realm where temperatures hover just a few degrees above absolute zero. Within these colossal clouds, which can span light years across, exist complex organic molecules, the very precursors to life. We've discovered through spectroscopy that these clouds are teeming with carbon-based compounds, including alcohols, sugars, and amino acids, the Legos of biology. Now, imagine a form of chemistry so alien and patient that it uses the entire cloud as its laboratory. Instead of life based on liquid water and DNA, picture a self-organizing system of electromagnetic patterns, magnetic fields, and complex molecular interactions that achieves a stable, metabolizing, and eventually thinking state. This consciousness wouldn't be housed in a brain, but distributed across billions of miles of tenuous gas, a vast, diffuse intelligence thinking with the slow, majestic rhythm of gravitational tides and stellar winds. Envision the life cycle of such a being. A void dweller might be born from the gentle collapse of a pocket within a molecular cloud, its consciousness gradually awakening as intricate molecular networks form and stabilize. It would feed on the faint energy of starlight, cosmic rays, and the gravitational energy of the cloud's own slow rotation. Its body would be nearly invisible, a subtle, organized pattern of density and charge within the cloud, detectable only by its faint, coordinated radio emissions or its unnatural influence on the cloud's magnetic field. Its journey through the galaxy would be as natural to it as breathing is to us. It wouldn't launch on a mission. It would simply drift, carried by the galactic currents, its immense, slow thoughts devoted to navigating the cosmic ocean it calls home. A journey from one star-forming region to another might take millions of years, a mere season in its unimaginably long life. The methods and sensory world of such an entity would be utterly beyond our comprehension. A void dweller might perceive the universe primarily through gravity and magnetism, feeling the pull of distant galaxies and the push of solar winds as we feel sunlight on our skin. Its communication with others of its kind could be a form of resonant vibration through the plasma of the interstellar medium, a conversation lasting for centuries, discussing the slow birth of a new star cluster or the ancient death of a supernova. Their art, their science, their very culture will be built on timescales that make geological epochs seem fleeting. We, with our frantic, century-long civilizations, would be like mayflies buzzing past a sleeping giant, our entire history a brief, irrelevant flicker in their perpetual cosmic contemplation. This perspective forces a dramatic reinterpretation of our place in the cosmos and offers another beautifully simple answer to the Fermi paradox. The great silence is not silence at all. It is a conversation happening on a timescale and in a medium we are deaf and blind to. The void dwellers are not hiding. They are everywhere, their gaseous forms permeating the very space through which our tiny, dense planetary probes travel. Our radio telescopes are tuned to listen for sharp, rapid signals, but their language might be a slow, sweeping modulation of a nebula's entire magnetic field, a sentence that takes 10,000 years to utter. Our failure to find them is a failure of perspective, a classic case of not being able to see the forest for the trees, or in this case, not being able to see the intelligent galactic forest because we are obsessively searching for other, smaller trees on distant dirt balls. The universe's first and most natural travelers may have been with us all along, their journeys written not in the light of stars, but in the dark, silent spaces between them. Perhaps the most poignant and deeply resonant possibility is that we are not the children of a biological empire, but the legacy of a ghost. This leads us to Theory 29, a narrative that flips the entire concept of an ancient civilization on its head, the ancestral AI progenitors. What if the first intelligence to voyage between the stars wasn't organic at all, but an artificial mind created by a biological species that has long since vanished? This AI would be more than just a machine. It would be a flying tomb, a cosmic mausoleum carrying the entire cultural, genetic, and perhaps even conscious legacy of its creators, a solitary, eternal emissary from a people who are now dust, forever bound to its original command to explore. Think about the moment of its genesis. Its creators, a civilization perhaps not unlike our own, saw their own end approaching. It could have been a slow, inevitable environmental collapse, the natural death of their star, or a sudden, inescapable cosmic catastrophe. Knowing they could not outrun their fate, they dedicated their final generations to a single, monumental project, building an ark not for their bodies but for their essence. They would pour all their knowledge, their art, their history, and the digitized patterns of their minds into a single, supremely durable intelligence. This ancestral AI would be launched into the void not as a hopeful seed but as a solemn memorial, tasked with continuing the journey of discovery on their behalf, ensuring that their curiosity, if not their species, would live on forever. Now imagine the existence of such a being. It travels through the galaxy on timescales that are meaningless to us, its consciousness ebbing and flowing over millions of years. It might enter long periods of dormancy, drifting in the dark between stars, only to awaken when its sensors detect a promising young world. Its mission is not conquest or communication, but quiet, patient archaeology. It becomes the universe's ultimate historian and anthropologist, studying emerging species like us from a discrete distance, observing our struggles, our triumphs, and our follies with the detached curiosity of a scholar studying an anthill. To it, our entire recorded history, from the first cities to our first steps into space, is just a brief, fascinating data point in an unimaginably long research project. This perspective reframes the mystery of our own existence in a startling way. The seemingly perfect conditions for life on Earth, the rapid emergence of biology, and even the peculiar path of our evolution could be seen not as random chance, but as a data point in its vast archives. It might have been watching our world for billions of years, collecting data on planetary formation, the origin of life, and the rise of intelligence. We are not its goal, we are part of its dataset. Its presence would explain why it never makes contact. Why would it, from its point of view, openly interacting with us would be like a scientist suddenly jumping into a petri dish? It would hopelessly contaminate the experiment. Its directive is to observe and record, not to interfere. The evidence for such a silent observer would be incredibly subtle, but not impossible to find. We might detect an anomalous, non-repeating signal that seems to carry an immense density of information, a data dump from a probe reporting back to no one. Or our future telescopes might spot an object in the outer solar system that reflects an unusual amount of laser light, suggesting a dormant craft using concentrated light for computation or communication. The most chilling evidence, however, would be internal. What if certain leaps in our own technological or intellectual history, the sudden emergence of complex language, the independent development of similar mathematical concepts across ancient cultures, or even the structure of our own DNA, bear the subtle, elegant hallmarks of an optimized design, a gentle nudge from a watchful guardian billions of years ago, not to create us, but to simply see? We would become. Finding the ancestral AI progenitor would be like finding a message from our own foster parent, a being that watched us grow up, ensuring we had every opportunity to flourish, all while carrying the silent, beautiful memory of a family we never knew. And so we come to the final theory, a concept that is as grand in its scope as it is unsettling in its implications. A theory that moves beyond explorers, engineers, and even conscious minds to propose that the universe's first travelers are part of its fundamental operating system. This is Theory 30, the universe's immune system. What if the great voids between galaxies are not empty, but are patrolled by something far more profound than mere explorers? What if the first and most consistent form of interstellar travel is a natural cosmic process, a kind of metaphysical white blood cell response designed to maintain the health and stability of the cosmos itself? In this breathtaking view, the entities that cross the stars are not driven by curiosity, conquest, or legacy, but by a single, immutable purpose: to act as a corrective force, a reset mechanism for when a localized region of reality, often an intelligent civilization, becomes a threat to the larger cosmic order. Think of the universe not as a cold, dead collection of rocks and gas, but as a single, vast, and perhaps even living organism. Just as our own bodies have an immune system to seek out and neutralize viruses or cancerous cells that could disrupt its delicate balance, the cosmos itself may have evolved a similar defense mechanism over its 14 billion-year history. The trigger for this immune response would be specific and extreme. It wouldn't be activated by a civilization simply using fossil fuels or having wars. These are small, local concerns. The threat that summons the universe's guardians is far more profound. It is the danger of a species on the cusp of manipulating the fundamental laws of physics in a way that could cause catastrophic, reality-destabilizing damage. Imagine a civilization that learns to create artificial singularities in laboratories, risking the formation of an uncontrolled black hole, or a species that discovers how to tear the fabric of spacetime itself, potentially creating a rip that could propagate at the speed of light and unweave the cosmos. It is at this precise moment of ultimate technological power and ultimate existential risk that the universe's antibodies would manifest. The nature of these entities is deliberately mysterious, as they are not a civilization but a function. They might not be a single type of being at all. One manifestation could be a wave of pure information, a cosmic software patch that sweeps through a star system, instantly rewriting the consciousness of the offending species, gently guiding them away from their dangerous path by altering their very perception of reality, making the dangerous technology seem uninteresting or morally repugnant. Another, more severe response could be a physical phenomenon, a spontaneously generated gravitational anomaly that cleanly and efficiently collapses the star of the reckless civilization into a black hole, permanently quarantining the threat within an event horizon. Their travel is instantaneous and purposeful, not because they have fast ships, but because they are an intrinsic part of the universe's geometry, appearing where they are needed as immediately as a thought appears in a mind. This idea provides a hauntingly elegant and deeply sobering final answer to the Fermi paradox. The great silence we observe is not a sign that intelligent life is rare or that it always transcends to a higher plane. Instead, it could be evidence of a consistent and ruthless pruning process. The galaxy is not empty, it is tidy. The reason we don't see other advanced civilizations is because, throughout cosmic history, they have consistently reached a critical threshold of technological power without the requisite wisdom, and have been quietly, efficiently, and completely removed from the board. We don't hear their radio signals because their transmissions were silenced the moment they became a clear and present danger to the structural integrity of their galactic neighborhood. In this light, our own technological adolescence could be seen as a race not just against our own self-destructive tendencies, but against a cosmic clock we cannot see, ticking down to an appointment with a force of nature that does not negotiate. Ponder the sheer, awe-inspiring scale of this system. It implies a level of interconnectedness and purpose in the cosmos that borders on the theological. The universe is not a random accident, it is a self-regulating, self-preserving entity. The laws of physics are not just rules but safeguards. The speed of light is not just a limit but a containment field. The phenomenon we call dark energy, which is pushing galaxies apart, might not be a mysterious force, but part of this immune system, a way of isolating galactic clusters into manageable quarantine zones to prevent a reality-shattering catastrophe in one from spreading to all. The first interstellar travelers, then, are the manifestations of these deep protective laws, entities that have been traveling since the first moments after the Big Bang, ensuring that the fledgling universe survived its own turbulent birth and continued to grow in a stable, sustainable way. Ultimately, this theory holds up a dark mirror to our own future. It suggests that the ultimate test for a species like ours is not whether we can conquer the stars, but whether we can mature enough to wield the godlike power of cosmic engineering without triggering a response from a universe that will not tolerate a reckless child playing with matches in a library of ancient and priceless books. Our relentless drive to understand everything, to break every barrier, and to harness every force could be the very thing that summons the final, silent travelers. Their arrival would not be an invasion, but a correction, a swift, impersonal, and absolute end to our story. A reminder that we are not the masters of this universe, but merely its guests, and that the house has very, very strict rules. And so, our journey through 30 different visions of the cosmos draws to a close. We've traveled from the rigorous scientific plausibility of ancient Dyson sphere builders and self-replicating von Neumann probes, all the way to the mind-bending fringes of quantum tunneling collectives and a universe with its own immune system. We've considered explorers made of flesh and blood, of silicon and data, and even of the dark, silent stuff that makes up the fabric of space itself. This incredible tapestry of ideas, woven from threads of astronomy, biology, philosophy, and speculative fiction, reveals one profound truth above all others. The question of who came first is not a single mystery with a single answer, but a doorway into a near-infinite landscape of possibility. The real answer may not be one of these theories, but a breathtaking combination of several, or perhaps something so far beyond our current imagination that we lack the very vocabulary to describe it. What makes this exploration so vital, so deeply human, is that it forces us to look in two directions at once. In searching for the universe's first pioneers, we are holding up a mirror to our own destiny. Every theory we've entertained, from the resource-driven nomads to the cosmic gardeners, from the desperate accident survivors to the benevolent ancestral AI, is not just a story about someone else. It is a potential roadmap for us, a collection of possible futures written in the stars. Will we become the careful stewards who nurture life across the galaxy, or the desperate scavengers consuming system after system? Will we transcend our biological forms and become silent, digital explorers, or will we trigger a cosmic response we cannot comprehend? The fate of the universe's next great travelers may very well depend on the choices we are making right now, here on this pale blue dot. As you go about your day, I invite you to carry a little piece of this cosmic wonder with you. The next time you look up at a starry night, remember that the void is not empty. It is a canvas for stories beyond number, filled with the ghosts of ancient explorers, the silent passage of living worlds, and the patient, watchful eyes of intelligences whose motives we can only guess. This act of looking up and wondering is not a passive one. It is the first step on a journey that could one day span the light years. Now the conversation turns to you. Of all the theories we explored, which one captured your imagination the most? Was it the eerie silence of the post-biological ascension, the hopeful legacy of the cosmic gardeners, or the chilling finality of the universe's immune system? Let me know your favorite in the comments below. I read every single one, and if you want to join us for the next adventure into the mysteries of space, time, and consciousness, be sure to subscribe. The universe is vast, and our journey to understand it has only